we're here with Methodic Exuberance with Pedro, and it's going to be using Maya and Houdini primarily. And I'll give an introduction. So Pedro is an architect, professor, procedural and computational designer based in Lima. He holds an MSc Computational Advanced Design Working Program. He's the co-founder of Lima, a computational design laboratory based in Lima, Peru, where he explores the limits of digital tools through digital prototypes and digital fabrication. He also works as a professor at Tech Department in Pontifical Catholic University of Peru, PUCP, procedural designer at Xvolve, and collaborator at Sensory Orbit. He's pushing the boundaries of digital design through digital procedural tools. So welcome, Pedro. And right before I'll give it over to you, I just want to mention to the people here that are attending that this is recorded as the registration form mentioned, and it's also written in the chat that you'll get an email on accessing the recording when it is processed. If you have any questions, please use the Q&A button. You'll see where there's all your Zoom buttons. There's a Q&A one, better to keep track of the questions there. And if you want to write in the chat, make sure you switch the chat to everyone. Otherwise, you're just writing to me. As much as I like your writing, I'm sure everyone else will like to see it as well. And just lastly, again, since it's recorded, keep in mind that not everyone learns at the same pace. So if you can't keep up during the webinar, remember that you can go back to the recording. We try not to stop too much so that we can get through the material and give you all as much information as possible. So nothing else from me. I'm gonna give it over to you, Pedro. I'll be here the entire duration and let you do your thing.
Thank you. Nice. I think that's good. I think I can share my screen right now. Let me see.
Yeah.
Just
let's make sure that that's working.
Yeah, of course. Can everyone see my screen?
Yes, for me, it's working fine.
Nice. Okay. So thank you so much for this invitation. And let me organize my Zoom here. Nice. Okay, this is Methodic Exuberance, episode 1. Hopefully there will be more episodes, who knows. Today I'll mostly be focusing on these 3 tools, Houdini. I will be working on this particular equation, Houdini plus Maya and Arnold. But mostly I will be working on Houdini. And because one of the most important things I want to cover today, it's the use of Arnold. But not Arnold as a regular render engine, but mostly as a tool that will help us to create data and create details, if you want to see in that way. So that's why I need more time to explain Arnold. So that's why I won't cover Arnold at the end of the session, but during my whole workflow. Okay. So Maya will be used mostly as a compositional software. However, at the end of this session, probably I will try to cover the use of Houdini engine, as this is a plugin that will help us to control Maya, to control Houdini inside Maya. But I will try to cover it at the end, as this particular tool requires, if you are using the apprentice version of Houdini, probably you won't be able to use this tool unless you have at least the Indie license, I think. So I will try to cover this at the end if I have time. Just for some technical questions, I will be using the 19.0 version of Houdini. I know that some weeks ago it was released, the latest version, 19.5. So if you have that version, no worries, there won't be any problem. Just use it. Most of the nodes that I will be using are part of the SideFX Labs plugin. I'm sure that this particular tool, it's part of Houdini 19. I mean, you can find it easily, but just in case if you cannot find this particular tool while we are working, try to look for it in the web page of SideFX and download it. But I'm sure that won't be any problem right now. I just want to show, I just want to tell you quite a bit about me. I'm an architect from Peru, from the university, Ricardo Palma University here in Peru. And I'm a student, well, ex-student of the Design Morphings Master Program. We finished the master 2 months ago, I think. But what I'm doing right now, I'm the co-founder and CEO of Lima, not the city, but Lima is the acronym of Immersive Laboratories of Architectural Mechanisms, which is my own studio in where I mostly do academic stuff. We create courses, we do workshops, we work with other universities, we work as a consultancy office as well. We work with other offices, trying to help them to introduce digital tools in their workflow and things like that. I'm also work as a professor here in Peru, at the technology department of the architectural faculty here in the Pontifical University Catholic of Peru, which is one of the most schools here in the region. So I've been working as a professor since I finished my undergraduate school back in 2012, more or less. So yeah, I've been working as a professor like a lot. I'm really excited to tell you that I will be here teaching and working here in the Design Morphing Master Program as well. Some fresh news that I am a verified design creator at Illusory. So we're working in a really huge thing. So please stay tuned. Try to follow Illusory's Instagram account, please. And last but not least, I'm a procedural designer in Excel right now, mostly working in metaverse, in the metaverse field. So before going into the software, I just want to show you a little bit about my way of thinking, because what I expect to do today is for you not to copy whatever I do here, but to understand the logic behind of what I do. I think that's the most important thing for you today. So I want to show you some pictures of the work that I did during the master and in my personal everyday life. So this picture was part of the master program I did with my partner, Nadia Kutreva. So we both discussed from the beginning the best way to design, the best approach for designing in a digital world. So we mostly came to this point in where we didn't want to copy organic languages, but we were inspired by organic language, but tried to power them by trying to create a new one, exaggerating natural language. So that's something that I found interesting in my everyday life, not trying to copy organic language, but trying to exaggerate it using digital tools. That's something that I have, that it's possible to do it with digital tools. However, the way we try to design and the way I design personally, I always try to look for several outputs or several alternatives for the same problem. So at the end, my goal is not to have just one model, but several models at the same time. That's why I found in procedural tools like the best ally or the best tool to work with, because it gives me the possibility to study several outputs at the same time and control every step on this process. It doesn't matter if we are creating the most abstract thing or the most rational thing, it doesn't matter. So that's why I don't want you to stick with a particular aesthetic, but with the logic behind any kind of aesthetic. So I started using Houdini more or less in January, I think. So I've been using Houdini like for 6 months professionally, and I'm still learning, of course. So to summarize my idea, basically the way I see the design, it's designed like the liquid is my material, but in the digital world, the liquid is basically the data. So what I'm really interested in is to discover the power of the data, how to design with data, how to treat the data, how to control the data. That's why I found Houdini, the perfect tool to start designing. So before the master, my way of work, I tried to do the same way of thinking, but I mostly design manually. Back in the days, I used to use Rhino, Grasshopper, Maya. I do it today as well, but mostly I work procedurally. So when I discovered Houdini, so my way of thinking changed a lot, basically because it forced me to organize the most abstract thing or the most rational thing everything has an order and steps. That's what I found something very interesting about the procedural design. So I can work with the most abstract thing as this is, or the most rational thing as a building, using the same logic, but not the same aesthetic, but the same logic, because I'm more interested in the logic rather than a particular aesthetic. So today I want to focus on two particular exercises. These look easy, as you may see. However, there is a lot of things that to cover today, because I want to discuss a lot about the logics rather than the regular modeling part. And as well as I need time to explain the logics behind Arnold. And as I know, Maya will crash a couple of times today. I need to have time for the rendering part. Okay, so please bear with me because there's a lot of things I want to cover. Hopefully I can do it today. But if not, if for some reason I cannot cover everything, don't feel bad, because I will try to cover some things in my personal Instagram account. I always share resources in my Instagram account, so try to follow me if you can. This is more or less what I expected to do today. As you may see, some topics are in gray color. It's because I will try to cover them at the end of the session. And please feel free to use the Q&A section today. No matter what kind of question do you have, the more questions, the better. And if you are shy as me, you can follow me on my personal Instagram account or in my business account as well. Write to me anytime, asking me whatever you want. I really love knowing new people to chat. So this is more or less what I wanted to show you today. And I think we can start now. If you cannot see my screen, please let me know. You should be able to see my Houdini window. So I hope it's okay. So cool, nice. Okay, this is more or less how Houdini. I will turn my camera off just to make this faster. Cool. Okay, just for you to know, this is more or less how Houdini starts from the beginning. So the best way to start working with Houdini is to readapt the general workspace here by changing viewports and that kind of stuff. So the way I usually do, I mean, I have my own workspace here. This is what we are going to do first to organize the viewport, the workspace, sorry. So the way to do it, it's by splitting these small viewports, okay, with this logic. I will split the main viewport here by clicking on, not on this, by clicking on this particular viewport layout. Click on it. No, sorry, up here in the triangle here, up here. And I will split left, right here. Not because I want to have two viewports, but because here in the middle, I want to have my main network. Okay, because we are going to create our scripts at the middle here. So I need space for it. So what I will do here is I will go to the plus icon here, up here, next paint tab type, and here I will click on network view. Yeah, this will be our main space to work right now. I will close the scene view. And apart from it, we need to have in hand the parameter next to it. That's nice. And down here, I need to work with something that is called the geometry spreadsheet. I will explain this later, but I need to have this particular tab next to me. So here, down here, I will go to the plus icon. I will go to the new paint tab type. And if I remember well, it's on inspector. Yeah, geometry spreadsheet. So that's basically what I do anytime I start using Houdini the first time. If you are happy with this particular organization, please save it by going into the workspace button up here and save it with the name you want. Okay, I have mine here. It's the same. And I think we are ready to go. Keep in mind something. Houdini is based on basically three main core attributes. And I think this is important to know before entering into Houdini. The key attributes of Houdini are nodes, parameters, and attributes. Okay, that's everything you need to know about Houdini, by the way. Everything we create here in the viewport has its own representation as nodes. Okay, and the way we tweak them, or the way we edit whatever we do in Houdini, can be tweaked with parameters. Those are these sliders that let us change and tweak whatever we are doing in Houdini. And the question is, what are those things that we are tweaking? What are those things that we are tweaking? Well, basically are attributes. Attributes are, it's basically the data of whatever we are doing here. So what kind of attribute we can work with here in Houdini? Well, basically, for example, we can work with positions, we can work with colors, we can work with scales, we can work with, I don't know, velocity. Anyway, there are tons of attributes here inside Houdini we can start working with that basically are numbers that could be floats, integers, and also could be strings. And the way we see them and the way we interact with them is by using the geometry spreadsheet, because here it's where we are going to be able to see all the attributes. Doesn't matter what kind of attributes they are. That's why it's important to have the viewport here, the network here, the geometry spreadsheet here, and the parameter up here. Got it? That's why I organized my Houdini in this way. So as you may see here, in the geometry spreadsheet, we have these 4 buttons. Okay, those are like the places our attributes could be stored, because we can store attributes on the points, we can store attributes on the vertex. And remember, points and vertex here are not the exact same thing, are quite a bit different. We also have here the primitives and the detail, which is quite a bit interesting here. The idea behind details. Details is any type of, I mean, it's a kind of empty vessel where we can place particular attributes that we don't want to store in neither of these particular spaces. Okay, so the way to start, let's start. We will be working with the first exercise right now. So the way to start here is, first of all, being sure that we are in the proper viewport. Okay, because here in Houdini we have different viewports. We can start creating nodes. Okay, everything here will be controlled by nodes. Got it? So by default, our network view, it's on the object view network. Okay. So for example, if we want to create materials, we can go to the material network. It would look similar, but once you press tab here, the nodes that will appear here are nodes that work mostly for material creation, right? If we go to, I don't know, to output, probably here the nodes will be different, as these nodes mostly work for rendering, for the rendering process. And so that's why if we want to work with geometry, we need to stay in the object network, right? So just for you to know, if you wanna zoom in, zooming out with the wheel, if you wanna orbit, left click. If you wanna zoom, right click, and if you wanna pan, click on the wheel of the mouse. Simple as that. What I really suggest you, if you are starting with Houdini, please do not play with these buttons up here. Okay, let's try not to play with them, not until you are confident enough with Houdini. Okay, the best way to start it's by creating all the nodes from scratch here in the network, right? Okay, what I will do here right now, we're going to work with just one geometry, which is, if I have the picture here, I don't remember where's my picture here. Let me look for the picture just to see it as reference. Okay, what we are going to work with is with this particular exercise right now. So we have this particular base mesh in where we are going to extract, from where we are going to extract data, right? So we can treat it just as a one geometry. However, in the second exercise, probably we are going to split them. Probably this will be one geometry, probably this will be another one, and another one. This is really important here because, let's close this, because the the first thing we need to do here in Houdini is press tab and write the node geometry, because this is a kind of an empty vessel in where inside we are going to build our node, our whole structure, our whole network. And here we can have several geometry nodes, and each one of these nodes can contain a whole procedure for a different geometry, or we can relate whatever we are doing here can be related in the next one, and the next one, the second one can be related to the third one, and so on, so on. So this is up to you. It depends a lot of how you organize your way of work. But just in case, if you want to have these grids, I always love to use a grid in Houdini. If you want to activate this grid in the network view, press D from display and look for the grid spacing. I normally use these values for the grid. Now my node will stick on the grid. For me, that's perfect. I always use a lot the shape palette here, down here, by pressing Z in the keyboard, because I really want to use circular nodes. That's a personal taste, by the way. So let's go inside it. As you may see here, the path is quite a bit different. We are in the object network view, but inside the first geo node. Okay, from now we are ready to start. Okay, so the first thing I need to do, we have two options here. We can use test geometries, because here in Houdini we have some test geometries to start working with, or we can import geometry as well. So let's do both. If I want to start with the bust, let's select the template height. That's enough. I will change it to circular. And we are ready to go. Just in case, if I want to import, I can use the node file. This node is for importing and exporting as well. This by default use a cube. So as you may see here, every node has, let's put it like that. Every node has 4 different buttons here, okay? The blue one, it's for activating it or disable it or hiding it. If I want to see what's happening on this node, I click on the blue icon here as well. Next to it, we have this magenta button that basically is for previewing another node. So if I, for example, want to work with this first one and I want to see what's happening in another node, just as a reference, I click on the magenta button and I can see both of them in the viewport. This is extremely useful when we are working with several procedures at the same time. If for some reason I want to, no, let's go up. If for some reason I want to cancel or I want to bypass whatever is happening on this node, I click on the yellow button. Okay. So for example, if I want to, let's try to use transform node. The transform node is for tweaking, to do basic tweaking, translate, rotate, scale. So basic things. I will connect this one like that, right? So for example, I can scale the map. And for example, I can use another node that it's called scatter, to scatter points. This node will scatter points, as the name suggests. However, let's imagine that I don't want to use the transform node anymore, or I want to bypass it. I just click on the yellow button. So whatever was happening inside here, it won't work anymore. However, it's still there. So this is quite a bit different from Grasshopper. As we remember, for those who comes from Grasshopper, we used to have this logic from left to right. And when I want to cancel or bypass this particular node, once I cancel this node, from this point onwards, everything will stop working. Remember that? In this case, it's different. What we do by pressing the yellow button is we disable the node or we bypass the node so the data goes directly to the next node. And that's extremely, extremely useful. Just in case, if you don't want to use, if you want to erase this node, you can do it, and that's enough. The wire will readapt automatically. Okay. So what I will do here, I will import another model by going into the geometry file button next to it. And let's look for the model. I'm not sure if I shared this reference model in the link, but if you don't find it on the link we shared, please let me know so I can share it to you then again. But but if you cannot find this model, which is mostly the same. You can use the test geometry. This test geometry node is the same. Okay, so I think we can start right now. I will erase this. So first of all, as you may see here, the test geometry template, it's on the origin. However, my file node is not. I don't know where it is. It's down here. Okay. The first thing I need to do is I need to put this particular model into the origin. So one of the most used nodes here, and I really suggest you to use this node, is the match size node. This match size node, one of the things that this particular node does is it will help me to put my model in the origin automatically by default. Okay. Or I can use this to reshape my model using another one as a reference. I will press here Shift S just to change the wire style. I don't want to use this style, so I press Shift S just in case. So what I will do here, I will move it. My model. I want to justify my model, putting the bottom part of a model right on the Z plane. So what I will do is I will justify in the Y direction by going to minimum, and it will go up. That's nice. That's nice. So now I have two models here. So let's have this model as a reference. I need to make this second one bigger. One way to do it is by using the transform node. If I connect the transform node here, I can make it this bigger, and I can use the second one as a reference, as you may see here. Okay, let's make it quite a bit bigger. I mean, this is not exact, but just for you to understand the logic here. Nice. However, as you may see here, this particular model it's really high poly. The second one is not. So how can I increase the resolution of this particular model? It's by using the subdivide node here. By default, it works. It divides with the Catmull-Clark algorithm. So that's nice for me. Maybe we can increase it a little bit more, like 2 or 3. That's nice. So from this point onward, I need to have the possibility to choose between them, between both of them. So the way to do it is by using the switch node. You can grab both nodes, connect it into it, and that's nice. That's enough. So here inside the switch node, we have this parameter, the select input node. So you can select from 0 to 1. That's nice. So I will be working with the number 1. Cool. So next thing, before doing any kind of simulation here, I need to close the model. I need to have a closed mesh, and I need to raise this tongue. So first of all, what I want to do is let's erase whatever is happening inside here, okay? Because this particular piece inside here probably will give us problems later. So the way to do it, it's by using the delete node. Okay. The delete node. Delete node has this option that is called bounding volume. If we go to bounding volume and enable it, we will have the possibility to choose between a box or a sphere as a bounding geometry that will be help me to erase whatever it's inside or inside it. So I can reduce its size. By the way, if you click with the middle mouse here on each parameter, this ruler will appear, and you could just move it with the mouse, with the middle mouse pressed, by the way. So if I click on this gizmo node on the left, I can move manually whatever is happening here to erase what I don't want to use right now. Okay, I will try to make this faster. I'm pressing Shift, by the way, to change this particular volume in its origin. So on this particular case, I am not able to see what's happening inside because my model is not transparent. So what I usually do, and this is going to be quite a bit of coding right now, what I normally do when I want to interact with the interior part of a model, I usually make the model transparent. So the way I do it is by using a very small code here. With the attributes wrangle, we have the possibility to write any kind of code. Okay, today I'm not going to focus on doing VEX, which is the language for coding here in Houdini. I won't do VEX. Mostly we will be working with Bobs, which is almost the same, but it's more visual. But the next week, probably you will be working with VEX. So if you are interested in coding, you should come back next week. But for now, I will be doing very small piece of code here. What I will be doing here, I want to have the possibility to tweak values for transparency or values of the alpha channel. So the way to do it here is very easy. It's just by saying what I want and what I have. What I want is I want to change values of the alpha channel, and the alpha channel is a float basically. So I need to put float, put the add letter, and put the name of this particular attribute. So the attribute for transparency, it's alpha. Okay, like that, with uppercase at the beginning. This is the name of the attribute for transparency. It's alpha. So what I want to do is I want to have the possibility to change this value. This is the way you call an attribute. And if you put and this value goes from 0 to 1. So if I put 0.5 here, semicolon, and click outside, you will see that, let's change it to flat shaded. You will see that our model now is transparent. If I reduce this to 1, almost transparency. That's nice. That's everything you need to know. Let's put alpha. Something like it. So now I have the possibility to see what's happening inside. We'll try to move it here to erase the tongue. Like that, like that. I think that's enough. Okay, as you may see here, this is manual work. Okay, so that means that if I change the model from this one to this another one, I need to double check whatever is happening here. So probably we need to move the delete node again. Okay. Or you can create a copy of it and change the second one. Okay, keep that in mind. Keep that in mind. However, I will be working with number 1. Cool. Now I can bypass this node. That's enough for today. And next thing, I need to close the model right now. Let's close it by using polyfill. Okay, by default, this works in quads, but I don't want to use quads right now. Let's go to flat wire shaded, and I will change this quad to triangle. Okay, to keep it as cleaner as I can. So inside it's closed as well. Cool. So then what I will do is I will combine everything here in just one model, because as I see here, the eyes and the general skin are like 2 different geometries. I want to combine them in just one clean mesh. So the way to do it, first of all, I will put transform node here, just in case, even though I won't change it. I won't change anything here. So the way to do this, the best way to clean this model, is by changing the general geometry type here. Right now we are working in polygons, as you may see here. So I will go to BDB. I will go to BDB from polygon. Basically what I do with BDB, it's we convert this particular geometry into a set of voxels that just contains data, and we can do whatever we want with this data. Okay. Normally, BDB is normally used for creating and modeling clouds, fog, smoke, fire, you know. So in this case, we can convert our geometry in a BDB, in a volume, in a set of voxels. If I click on the eye icon here, we can see whatever is happening here. We have created 326 voxels. Okay. But of course, I need to increase this value. I need to have more voxels here because I need to recover my resolution, my previous resolution. So the way to do it is by making the voxels smaller. So the way to do it is by changing this number into a smaller value. And maybe we can go even smaller. And if you want, you can go even smaller. I won't do it. I won't go smaller. Just because I'm live streaming and I don't want to crash my computer, just in case. Then what I usually do when using BDB, I reshape the BDB just to reorganize the order of the voxels. So probably I will, at the end, I will have quite a bit less voxels. Here I'm using 1.1 million. Probably here will be quite a bit less, or maybe more, I don't know. Oh, it's almost the same. Anyway. And then I convert it back, convert BDB. I convert it into polygon. Right now it's a polygon again. However, as you may see here, the eye that was previously an independent model, now it's part of the final model. That's nice. So why did I do that? It's because in order to get this kind of models, this kind of organic on curvy models, we need to scatter points on the mesh, and we need to use we need to create several steps of these points, but moving them on the mesh. However, I will use a curly noise that will help me to move those points around circles, something like it. So if I have, for example, a model inside another model inside my general volume, some points will scatter in on the inside part, but I don't want that to happen. That's why I need to clean my mesh first, and then I will scatter points that I will move around the surface, right? I will close this. Got it. So what's next? I can use the scatter node. Scatter. And as you may see, I have a certain amount of points scattered randomly on the mesh. But it's using the whole mesh, as you may see here, right? You can play with it with the amount of points here. You can play with the Z that change basically the position. You can play with the relaxation attribute down here if you want to make it more homogeneous. Just increase this value if you want to make it more randomly or more relaxed, something like that. However, I don't want the points to scatter around the whole model. Okay, I just want I'm interested in just using this area of the model, or maybe this area, but not the rest. That's something really common here in Houdini. So how can I say to Houdini, I just want you to scatter points on this area? Well, I need to create an attribute that is called mask. So how can I create a mask here? There are several ways, but the way I want to show you, it's by doing manual work. If we go to attribute paint, we can create an attribute based on color. This by default will create an attribute that is called mask. So if I click on the eye button, you will see that now we have a mask attribute stored on the points. However, this particular mask attribute, for now, it doesn't have any kind of value because we didn't do anything. So if we see on the spreadsheet, we are on the points, we have the mask attribute, everything is in 0 because we haven't done anything for now. However, if I click on this particular node, and if you press enter on the viewport, you will see this brush. You can increase the brush by moving the wheel of the mouse. And for example, you can paint here. It should paint. Why is it not painting? Let's see the other. Okay, it was there. I don't know why it was not painting. Okay, let's do an attribute mask again. do it next to it. Okay, now I can paint it. So what I will do here, I will paint this area because this is the area I want to start working with. So by painting here, what I'm saying is later, I will ask Houdini to scatter points just on this particular area. Maybe only on this part. So now I don't want to include the ears. So I press Ctrl and I erase it. If you want to smooth those borders, just press Shift and start painting around the borders. Okay. If you make this brush bigger, you can smooth it faster. That's enough. That's enough. Let's put this into here. Okay, that's nice. However, if I go to scatter, you will see that the points again are scattering around the whole model. I don't want it to scatter around the whole model, but around whatever is happening in the mask. So I need to change some values here. I will go to the density attribute up here, and I will change this density to mask. If I change into mask, what I'm saying is scatter points, please, but only on the mask attribute by using mask attribute as an input data. That's why now this starts happening. Is there a way to use symmetry while painting? Yeah. If we want to use symmetry while painting, what I normally use is an attribute mirror here. I will put attribute mirror at the end. And let's see if we are doing it correctly. Oh, first of all, I need to set the attribute here by changing group type. I think it's, no, let's keep it like that. Changing the attribute here into other attributes and saying that we want to make a mirror on the mask. See if that works. Why it's not working here? Maybe mirroring. This should work. I don't know why it's not working. Maybe I did something. I did something wrong. Okay, it need to be in the points, but it's not. I need to change it probably the direction here. Why it's not working? Turn out points. Yeah, it should work here. It should be 1 here. Okay, now it's working. Now it's working. So, but at the end, in this case, I'm not sure if we'll be able to see the color. Maybe if we use here color nodes. Let's use a color node here because we can paint our geometry. We can use the color. However, we can paint based on an attribute. Let's go to RAM from attribute. Let's see if we can paint it by using the mask. Yeah, now we can see. This is more or less what's happening with the mask right now. Okay, so those are for painting. Let's group them with the color up here. Nice. So now we have symmetry. Yeah, I can use this from the beginning, but as I'm live streaming, I won't try to push my computer to its limits. So I will try to not use the attribute mirror for now. I will try to maintain this very simple. And probably at the end of our simulation, we can use another symmetry node because this particular node, it's mirroring the attribute, but we can also mirror the geometry by using, you can use mirror if you want, or you can use symmetrize. Oh, let's see. Come on. Anyway, you can use symmetry as well, but we will use it later. We will use this later. So in what I was standing, my whole node moved. Okay, let's keep it like that. So that's nice. So what I will do next, I will reduce the amount of points here. I will change quite a bit. Let's turn the reference on just to see what's happening here. Sorry, I need to move everything down here just to keep the order. Nice. So before doing this kind of simulation, first of all, I need to connect points here. So what I'm seeing here, for example, is a movement of points that are moving. So before moving, I need to link them in lines. So then those lines can be deformed around the surface. So what I will do here is I will grab this node that is called connect adjacent points. This will help me to connect all the points. Let's turn this off. This node will help me to connect all the points depending on the radius value. Okay. How to paint the object while in the attribute node. Okay. For those who are stuck here, for some reason my second model didn't work. Try to use the test geometry to paint your node. If you want to activate this particular node, you need to press enter on the viewport here, right? If you have this camera activated down here, you won't be able to see anything on the viewport. First of all, let me give you a very quick trick here. If you want to focus a node inside your viewport, just press F. If you want to activate a node, press enter. But while pressing enter, while having a node activated here, you won't have the possibility to focus your model. Okay. If you want to focus your model again, you need to click on this camera and press F. Right. Don't forget to press F, enter here. Okay, where I was standing here. Okay, now what I will do is I will join the points here. Nothing's happening because I need to go to adjacent points. Okay. Okay, something is happening here, yes, but it's too much, right? So what I will do is I will reduce the amount of search points. Let's see. Or what we can do, probably because it's too much, even the radius is too small. So what I can do here is maybe I can increase the size of the general model, like 5, for example. Then I can come back again. Let's wait. Nice. As I increase this value, probably I need to reduce this BDB because now we have too much voxels. Maybe we can go to 0.1. Just to make this faster, you know. Yeah, now it's faster. Now with this node, the same radius reacts completely different, just because I changed the scale. Keep that in mind. So here I will reduce this value probably quite a bit less, more or less like that. Yeah. Okay, you can play with those sliders as much as you want. However, be mindful that put Houdini to its limits. It's really easy here, so be mindful about it. Be mindful about it. Before doing anything, I will save my file here. This way. Let me show you something. While saving Houdini files, I really suggest you to start creating project folders for it, like Maya. And when you work with Maya, before start saving anything, you need to create a folder project, a project folder for it, in where you store all your files, assets, textures, whatever you're using on a particular file. So the way to do it here is by going into File, and before saving it, I really suggest you to go to New Project here, and I will set here on path. I will create a folder here that will be called Methodic Exuberance Webinar Project. So inside here, I will put my project folder, Methodic Webinar, accept, and my project name will be called the same, webinar. That's enough. I accept it. Then I set the project. This is very similar in Maya, by the way. accept it, and now you're ready to save. You put save or save as, and by default, it will be saved inside this particular folder. So let's go inside here. Okay, this is the way. And here I will put Methodic file 1. Simple as that. So I don't know why did it stop working. This shouldn't stop working, but anyway. Great, we are here. So next thing, what I want to do here is I want to transform those curves around my previous geometry. So a good way to do it, a good way to transform those points, I mean, it's to move in using vector data, right? So the way to do it is by using the attribute bob, or we can use vex here, but for me, it's easier to do it by using bobs. Okay. Bobs is more or less another way to see code in here. This is more similar to Grasshopper, in where we have an input, we have output here. But this input and output, it's based on the previous geometry we're going to work with, right? So I can connect it into here. And if I go inside here, what I want to do is I want to use a curl noise. The curl noise will give me the possibility to do this kind of simulation. So what I will do here is very simple. I will use an add node and the curl noise, because what I want to do is I want to grab the actual position of a point, and I want to change it depending of whatever it's happening in the curl noise. And I want to store this new position on the output. Simple as that. So here, what I want to do, or what I need to do, is I need to play with those particular parameters. So to get this particular output, what we need to do is we need to change the noise type to simplex noise. And let's play a little bit with those parameters. Here I use 0.1. By the way, I'm reading my notes. Okay, that's something I really suggest you. I start using a notepad to write a lot of things from here. That's the best way. That's the best way to learn Houdini. Okay. However, nothing is happening unless I change my amplitude. I can see something happening. But what I want to do is I want to repeat this process each frame here. So what I want to do is in the first frame, I want this particular value to happen. In the frame 2, I want this to happen again, depending on the previous one, and so on, so on, so on. So basically what I need to create here is an animation. Using the attribute bob as it is by default, well, it won't help me. So what I need to do is I need to create, a process in where this particular node runs each time the frame runs. So the way to do it is by using a solver. The solver. Solver looks like that. So what I will do here is I will grab this particular node, Control X. I will connect my model here. I will go inside and I will paste my node here. So here I'm connecting the previous frame to this particular node. Okay. So something will start happening while moving the timeline. That's nice. And of course, this will get messy very easily. But the good thing is that something is happening, and that's okay. That's okay. Then what I will do here, it's in order to get those curve lines, I need to increase the amount of points on each line. So for me, it will be easier to transform every curve here. The way to do it is by using the resample node. I will connect the resample node. The smaller this number, the more points we are going to get at the end. So let's reduce this number, the length. Let's go like 0.05. You will see that I have more points. Let's reduce even more. And let's say that I want to treat them as subdivision curves. So when I press play, you will see that now our curves are transforming more or less as we want to, as we want it to have, to be, That's nice. We're getting there. Then what I will do is I randomize attributes. What I wanted to happen is that I want this animation, but however, I want to apply some colors on it. Why? Because what I want to do at the end, if you may see this picture, let's clean on it. You may see that, for example, this particular part of the model looks similar than the layer below. And here we have two layers that look similar. It's because all of them were simulated in just one time, just once. However, we extract them, we separate them depending of certain type of attributes. What kind of attributes? I separated them using color attributes. So I create 4 color layers, and then I use this data to separate them in four types. So I said, Houdini, okay, create colors randomly, but just 4, and then I split them using those values. So that's for me easier to control them later when we go to Maya, or if we are going to create materials even in Houdini. That's the best thing to do if we want to control things here. So that's why inside here I said, okay, grab all the colors. Grab all the curves and start randomize colors on it, but just using 2 values here. Let's make it this easier. I will use 2 values, but not on the points, but the primitives. Okay. So here I will reduce the dimensions just to see the color, more or less. You can see black and yellow. That's nice, but we can change the values. Maybe 1 here. You can put 1.0 to see another color here. And you can change the probability of those colors. Remember, this is randomly. Okay, this is random. But let's keep it like that. I like it how it looks like. Nice. So for me, this will help me. This will help me to organize later all the pieces that I'm creating right now. So that's nice. But my problem here is I don't want this particular simulation to happen randomly at it's happening right now. I don't want it to be that chaotic. I want it to happen at the top of my mesh. What mesh? This one, right? So what I will do here is pay attention with this part, please. This is quite a bit tricky. Okay. I will grab whatever is happening. It could be this model, it could be that model. I will grab whatever is happening on this particular output by using a null. The null node, it's a completely empty node in Houdini. You can use it to do a kind of a shortcut at this kind of path to organize your model, or you can use the null node to create new parameters as well. Probably I can show you this later. I will create a null just to maintain this organized, and I will put here base mesh. And I will connect this onto the first output. It could be whatever, okay? You can connect to whatever of those inputs. I will just use the 4th one. Why? Because inside the node here, we have more inputs there. So what I did previously, I connect my base mesh to the 4th input. That's the way to say it. Now we can import my mesh inside the solver. To what? Because I want to use the rate node to project whatever it's happening on this simulation to the mesh. If I change this to minimum distance, you will see that now this simulation, it's being projected on the mesh. Okay. Something is happening, almost nothing, doesn't matter, no worries. We need to play a little bit probably with the points. Maybe it's a good time to add more points, change a little bit. See, and something will start happening, right? As soon as you have more points scattered on your mesh, probably this will look different. However, this doesn't look as the picture that I showed you previously, right? Yeah, it's because I need to add more things here. Because as you may see here, something is happening on the simulation. What I want it to happen, I want to store, even every step can be stored on my model. So what I need to do is I need to recover the previous steps. How? By using a train node. If you use a train node, after the solver, for example, if I am on 48 frame, I can increase the trail length to see the previous node, the previous steps. So if we go to the 20 step, we will be able to see whatever happened in the previous 20 frames. So that's a good way to start creating a more complex shape. And that's basically what I did to create this particular piece, right? So let's do not exaggerate for now. Let's use just 5 or 7 because I don't want to crash my computer. So let's put it like, let's keep it like that for now. So let's check it. It's working. I mean, that's nice. It's working fine. If, by the way, if you want to change this, if you want to change the seed, you can do it, but it will force you to run again the simulation. Okay, let's keep it like that, something like it. That's enough. Okay, for now I will be working this simple, because I don't want to wait a lot for simulating yet. Okay. So that's nice. Let's continue. If you want to use if you want to use a mirror node, you can use it. You can do it by using the symmetrize node. By default, it's been reflected in the y direction. You just need to change it from y to x. And now you have a symmetry. That's pretty fine. You can still play with the simulation here while having the symmetrize node activated to see what's happening here. Looks nice. Okay. Try to play with any model you may have. Okay. Let's put it like that. That looks nice. Cool. Cool. I will try to change a little bit. Maybe more homogeneous. Yeah, that looks fine. I will increase the trail just a little bit. Symmetrize it. Maybe I can change the direction. No, that's okay. Okay. So that's fine. I can continue now. So what I will try to do is I will try to fix all the polygonal curves. You know, this kind of angles that I don't really like. Just simple by using the resample node. As we did inside the solver. This is really easy to do. What I will do here, I will reduce this value, maybe 0.02. That's nice. Subdivision. And after it, probably I will use the smooth node. Cool. So if we increase this value, the strength, it will make those curves smoother. That's great. Looking cool. Looking cool. Keep in mind that I'm using few lines just to make this webinar faster, because I don't want to wait a lot of time by simulating. So then, what next? Remember that I use a node inside here to create colors, to randomize the colors. Now it's a good time to separate them. I want to start treat them separately. So the way to do it, there is one node here in Houdini that will help me to separate a model depending of certain types of attributes. If we use the partition node, we click on it. Here we will have the possibility to split our model depending of something. In this case, depending of the color or transparency. For now, I just want to work with the color. So what this is doing, if I click on the I button here, we will see that we have created. Oh, come on, it's not working. Okay, let's go into here. Okay, I will make a screenshot here just for you to show you what's happening here. Okay, it didn't work. Anyway, it didn't work anyway. So what I'm doing here is I'm creating two groups based on color, those colors. So I have 2006, 610, 898 primitives on the first group, and we have another group. So that means that now I can extract them in different nodes. Okay. So the way to do it, now that I have the possibility to choose between groups, I can use the blast node. Blast node will help me to separate them. I will copy twice and I will connect them. What I will do, we need to call whatever group we did previously. And we have two groups based on color. I have this one and I have the next one here. Then I separated them. So if you have a more complex, if you split is better, yeah, that could work. But for me, that's more than enough. That's more than enough. But yeah, that's a good point, because here in Houdini, the good thing about Houdini is that you can solve a problem with very different procedures, and that's really cool about Houdini. So if you ask someone for help, you will receive tons of answers and different answers, and I think that's good about Houdini. But yeah, split could work as well. But for now, I'm pretty fine by using the blast node. So then let's continue here. I think now it's a good time, if we prefer, what we can do here. We can even, for example, here we can randomize again the colors here, and we can create again another split here, and we can create another split here to start creating different amounts of groups. But I think 2 groups, it's more than enough right now. Okay, so what I will do here, we can convert those curves onto pipes. So the way to do it is by using the wireframe, the poly wireframe node, sorry, this one. But first of all, I will fuse them just in case. I will fuse the curves. I will reduce this amount just in case. And I will use the poly wire nodes. Let's go to flat. In order to avoid whatever is happening here, I will click on the prevent joint backlink, and that's enough. Let me see if I can change my background because it's too dark. Let's go to light. Right. Okay. That's better. Yeah, something is happening here. I will reduce this value. Let's go to 0.01. So that's good. That's cool. However, what I want to do here with this particular model, I want to have the possibility to control whatever is happening along the curve, because the only thing that I don't like about the polywire by default is that this particular radius applies to the whole curve from the beginning to the end. And I don't want to treat the curves like that. What I want to do is I want to have the possibility to control. Let's imagine that this is my curve. Keeping in mind that this is 1 and this is, sorry, 0 and 1. Okay, this is my range. This is my range. But let's imagine that I want this particular polywire node working this way, in where my radius, I have an A radius here, and then it goes thicker. Here I have another radius, you know what I mean? And then I go back to the final part, you know? I really want to control this polywire frame node like that. So there are tons of solutions for this. Can we export those curves to Rhino and work them? I think you can do it by using the IGS type. I think. I'm not sure, but you try to use the IGS file format to export. Try to export to Rhino. Hopefully that will work. And so the way to do it here, it's in order to control the curves better, what I will do here, I will tweak a little bit whatever it's happening here on the parameters. As I told you previously, those are the parameters that comes by default to control the polywire node. However, we can add more parameters if we want. So there's a way to do it. It's by going to the wheel up here, edit parameter interface. And here, it's quite a bit scaring first. But let me explain you this part, because this is really powerful about Houdini. Okay, we have here two lists, okay? Two lists. Well, number 3 are parameters. Okay, basically, those parameters are, depends on each one of those parameters here. But those parameters here are the ones that we are seeing next to it. Okay, so they are the same. They're the same. And the list on the left here are those parameters that we can include on our actual nodes. But of course, we need to create a kind of link for it to work. What kind of link? Let me show you. As I want to control the length, the diameter of this particular curve, what I need to do, what I would suggest you to do, is to grab a ramp float. This one, not the ramp color, the ramp float. Grab it and put it up here. And we can put a name. Okay, let's put wire radii. Copy it to the next name. And please keep this particular name in mind, because we are going to use it later. And we press accept. And what I have here is a ramp. If I change this ramp, nothing will happen because I need to link it to the wire radius. So once I change my particular radius here, I am seeing this particular ramp as the profile of the curves, right? So I need to link this data to whatever is happening here, the wire radius. So the way to do it. First of all, I need to create an attribute here. So I will press Alt-E. Alt-E is the command to activate this particular window to start doing coding, because we are going to do a very small code right now. Okay, the way to do it. First of all, I need to link this ramp flow to my wire radius. The way to do it is by creating this ramp. The way to do it is by pressing CH for channel and pressing ramp. With this, I'm saying I'm going to create a ramp. I'm going to create a slider, if you can see it that way. So this ramp should have a name. Here I need to put the name or put the path. In this case, I need to put the name. What name? Or which name? The one that I already put here, up here. So it's going to call wire radii. And here I can see the name. Nice. Next, I need to set, here's the solution. Then I need to specify which part of the curve I want to tweak. Here by default, as an example, it says 0.33. So that means that I'm going to tweak the point from 0 to 1, okay? The point 33 of the curve, but I want to work with the whole curve. So I need to create here an attribute that will let me work with the whole length of the curve. So what I will do is press accept for now. So what I will need to do here in the resample node, I will activate this attribute that is called curve view. This will give me the possibility to control the curve from its beginning to its end. So now let's go back to the polywire here. Let's press Alt-E. So now here, instead of putting a name from 0 to 1, I will call the curve view attribute, because I want to work with the whole curve. And then I need to put here the index that by default it's 1. And I think that's more than enough. However, something weird is happening. It's because we don't have the control of the final scale. So what I suggest you to do, it's whatever is happening here, multiply by a small number. maybe 0.1, just to see what's happening. Okay, that's better. You can start playing with it if you want. That's nice. Let me see how many points we have here. Maybe we can add them. You can add a little more. That's nice. Okay. Let's close this. And for now, I can use my ramp to change whatever is happening here. Of course, I will, no, I don't want to do that. I will select all the points here and I will change it to B-spline to make them smoother. Okay, I will select this one, maybe, but it's smoother. Maybe like it. You know, I will move it quite a bit here. Something like that. Okay, that's nice for me. And then I will clean my mesh. So I will change this to that. Maybe I can use them next to it. And I will go to BTB as well. So what I can do here, it's I can go BTB for polygon. Clean them up. I need to reduce this value. That's nice. Maybe quite a bit more like that. That's better. Maybe a little more. Nice. That's perfect. If I want to add details, probably I will reduce subdivisions here to have more spiky. Yeah, to have this kind of spiky, kind of spikes and sharp edges. Probably quite a bit more. Yeah, that's enough. Okay. So then we can continue by resampling the BDB. And then here, if I have the possibility to play with it a little bit more with two nodes. Oh, I mean, one node. We can use the reshape node, BDB reshape, this one. And what I normally do, I copy it twice. Because here we have the possibility to play with those particular operations. In one of them, I work with the delete, and in the second one, I work with the erode. So with this first one, I play with the inflation of the volume. Okay. This is up to you, by the way. And with the second one, I reduce. Oh, sorry, in the second one, yeah, in the second one, I reduce the general shape, something like that. That's nice. I really like how this is looking right now. Cool, cool. Then we can convert it again. Convert BDB. Let's select into here, changing the shape, convert it into polygon. Let's see. Let's go to flat wire. And as you may see here, we have these kind of imperfections on the border. So we need to clean or to smooth this general volume. We have to, from here, we have two possibilities. What we can do to smooth our mesh, we can use Delta Mush. This is one option. This will help me to smooth the general mesh. If you see that we start losing, if you see that you start losing a lot of the general shape, what you can do here in the reshape in the reshape node, it's to inflate a little bit the model, the BDB, or reduce the erosion here. You need to play with those, right? Let's keep it into 50. Another way to clean or to smooth the mesh is by using attribute blur. Why attribute blur? Because what we are going to do is we are going to tweak the position of each point. So by default, we work with the attribute, with the position attribute here. And if we increase the blurring iteration here, it will do more or less the same. It will clean the mesh or smooth the mesh. Okay. So two ways of cleaning the mesh. I will use for now attribute blur. For me, that's fine. Right. Let's continue. I don't want to write again this piece of code, so I can copy it next to it by pressing Alt. By the way, I will connect it, and that's enough. Cool. So you have two different options here. So for now, they are like intersecting each other. So what I can do here is I can increase the size of this one, depending on based on its centroid, or maybe in Maya I can do it as well. But for now, I want to change a little bit this particular model. It's too blobby for my taste. I will reduce the delay just to see it better. That's better. I will reduce it. Okay, that's nice. That's nice. Cool. So what's next? Let me move this up here. Great. So what we can do right now, it's we can expand one of them, because here in my model, as you may see here, for example, the middle one, this middle lining piece of model, it's quite a bit bigger. So it's like I scale it up depending on the centroid. So the way to do it is by using the transform node. However, let's put transform node here. If I put the transform node here, it will scale it up depending on its origin. And I don't want it to happen. I want to scale it up based on its centroid. So what I will do here, it's first of all, I will move this model to the origin. Then now I can scale it up. That's nice. When it's finished, I will grab again a match size node from here, and I will use the previous model as a reference to put it in its original location. Right. So now when I use the scale node, it will scale it up depending on its origin. So I can use the other node to see as a reference, more or less like that. Right. That's better. So on this particular process, let's just merge, by the way, just to see them together. So on this particular example, I use four layers rather than two. Here I just have two layers, but for this picture I use four. Okay, just keep that in mind. Okay, so let's continue. So if we can go back to tweak a little bit the model. Let's see. Why not? Maybe we can go back even here. Let's try. I will save my file. Let's not use the mask to see what happened. Let's go to the solver and let's see what's happened. It happens. Oh, that's nice. I think that's better. Yeah, let's do not use the mask for now. Yeah, that looks nice. So now the trail is better. Yep, that's better. But let's reduce a little bit the amount of trails, maybe like 5. Symmetrize, we can use that, or we can change it to the other direction as well. Let's keep it like that. Yeah, let's keep it like in 60. That's nice. So let's see what's happening here in the polywire. It's too messy right now. Why is it too messy? Why is it too messy? Maybe I can reduce it a little bit to 10. That's better. And here as well. Alt-E multiplied by 0.1. Yeah, no, it's quite a bit slower. Yeah, and let's merge it together. That's nice. I think that looks better. Looks like a real mask. That's nice. That's nice. I will save this model here. And again, if you want to explore more options here, what we can do is after this blast node, for example, what we can do is we can again go to attribute randomize here and use again attribute class primitive. We can use 2 values and we can play again with those numbers. Okay. The idea is just to have 2 different colors here. And again, from this part, we can split them. In this case, I would prefer to use blast node. Sorry, before using the blast node, I need to use partition. Sorry. Then the blast node. Then here I need to separate by color. So by default here, I will have three, how many? Yeah, I have 4 different grips. So previously I was using the color 25.0, 20, 25.5. So I just need to be careful about what kind of color I'm going to choose here. Let's see if this separated correctly. Yeah, now I need to select probably, let's see, 20, this one. And the second one, I need to select this one. Yeah. Now here I have one more option. So what I can do is I can copy this particular word plug here. And we can create as much subdivision as we want. So the reason why I'm doing this is just because to have the possibility to create different materials before when rendering. That's why. I'll make it bigger. I will copy this next to it. Come on, you can do it. Now it's quite a bit slow here, but anyway. So now I won't use this particular procedure anymore. Instead, I will be using this one. I will press Alt here, make this node, and that's that. Probably here, I will have the possibility to make it even bigger. Come on. Nice. Now I have 3 layers, 3 different layers. They are not the same, as you may see here. That's nice. It's looking great. It's looking great right now. Just to see how this is merging with the general shape, let's grab this base mesh. Let's put it into here. Let's put it into here just to keep the order. And that's more or less what we have. That's more or less the idea. I really suggest you to play with a higher value here in the scatter. What is my scatter node here? You can play with the scatter, you can change this value, or you can even increase the amount of trails. Okay. You can do it later as well. Nice. So I will save this file. Cool. So for now, we have 2 options here. We can apply colors here in Houdini to export them to Arnold, or we can create the material from scratch in Arnold. Okay, so that's what I'm going to do right now. So there are 2 ways to export here, whatever we are doing here. I will grab some null nodes, one for each one of the models, just to make this cleaner. I will put the merge here, and I will grab my 3 nulls. And a 4th one for the shape. Okay. So what I have here is layer 1, layer 1. So here I will have layer 2. Here I will have the number 3. And this is my mesh. Nice. Okay. There are two ways to export objects from here. If you don't have the indie version, I mean, if you are using the apprentice version, the best way to export something from here to Maya, it's by right clicking on it and save it, as a geometry, as an OBJ. Okay. However, I really suggest you to optimize your model before exporting anything from here. Okay. So let's see how many polygons do we have here. Almost 1 million. So I think we can reduce it. The best way to do it, we can use the poly reduce right now. So let's see our first model. This is more or less how we have. Almost 1 million. Maybe we can reduce it to 30%. So I change the percent before putting the node inside it, because this will take time to compute, depending of how much polygons do you have. That's why I try to be simple, because this is the process that usually takes more time to compute. How many 100? We can go with a bit less, without losing the general shape. That's nice. I think that's nice. I think that's great for now. For rendering, I think that's nice. So I will copy it to the next one. Bear with me, please, because this part, it's quite a bit slow. Optimizing a model takes time to compute. Reducing the amount of polygons takes time to compute. I will increase this one, maybe 40. Let's put it into maybe 50. How many points? Okay, it's manageable. Let's see the poly reduce here. How many polygons we have? Okay, we can put this into 40. And I think we are ready to go. 3 and the mesh. Yep. Let's save this. If you are using the apprentice version, go to Save, Geometry, and here select the OBJ option, because if you have the apprentice version, as I know, you won't have the possibility to export it as an FBX. So keep that in mind. If you have the free version, select the OBJ, click on it, and select your folder here, and put whatever name you want in here, and just then you start saving your file. If you have the India version, you can use the FBX wrap here. I will put one of each. First of all, I will save this one. The way to save it is by clicking on this output file. Let's go to the, by default, it's on the folder. This will be called layer 1.fbx. Keep that in mind. Press accept, save to disk, and let's go to the desktop just to double check if it worked correctly. Yeah, it's here, layer 1. That's nice. For now, I won't store any kind of attribute on the vertex, because we can store color attributes on the vertex, but for now, I won't do it. I will copy this particular node here, 1 for each. And here it's just easy. It's easy to change the number, save to disk. Here, 3, save to disk. And here, let's put the mesh. No, not the one, this one. Okay. Mesh. Nice. That is everything we need to do. Let's go to our folder just to double check it. Yes, they are there. As you may see properly, if you probably saw, I didn't invest time on creating the UV map. We have two options here. We can use an UV texture to create a UV projection of our models, because as you know, while rendering, the UV mapping process is extremely important. you can use here UV mapping or Labs Auto UV to create the UV map. However, the reason why I didn't on purpose, because I will try to solve this issue using Arnold, because we can solve this issue using Arnold as well. And I think we can do it faster using Arnold because if we use the Auto UV right now, it will take time to compute. Yeah, so for the sake of the time, I will solve this problem in Arnold, right? So I will save this file and I will open Maya. Okay. So let's see if there is questions here. I can see a question here. Can you pick a specific point in one of the baselines and control the radius there? If you're asking about the polywire here, the best way to control whatever is happening here, let's imagine that, let's do something funny. Let's go to the node curve here. This node is really funny. Let's press enter here and let's create a curve. I will click on this grid snapping and I will create a curve, very easy curve. Okay. No, not like that. A polyline here. Then I will select this curve and I will click on the fillet option and I will do a very quick curve. Nice. Nice. If I copy this particular node here, before doing anything here, I need to resample the curve. Let's try to resample it by using subdivision and try to reduce the amount of points, more or less like that. Okay, oh, 0.1, maybe too much. That's nice. Before using whatever I'm doing in the polywire, I need to activate the curve view attribute. So now I have the possibility to control, let's clear it. So now I have the possibility to control whatever is happening on this particular curve, reparameterize and add from 0 to 1. So if I want to control the middle, I just need to select 0.5. But what I did here on this particular node, I said, I want to control the whole curve from 0 to 1 based on a ramp, because my ramp, it's more like the graph mapper in Grasshopper. My graph, this is more, let's do it instead of talking about it. Let's click on it. Okay. I will delete all in the middle and I will make this bigger. As you may see here, this particular ramp goes from 0 to 1 in X and in Y. That's nice. At least for me, the most important thing right now is this value, the U value, because this one represents the radius, okay? So if I want to control, for example, the middle, which is this one, probably what I can do is I can create 2 more points here and I can increase this value. And as you will see, just the middle, it's been changing. If you want to make a sharper profile, you can select all the points here. Oh man, something is happening here. That's better. You can select all the points here and change it from spline to linear. And you could create a more exact profile here by doing something like that. I don't know. Whatever you want from here. Okay. If you want to have more resolution here, go back to the resample node, reduce the length, and you will get more resolution. Okay. So that's at least the best way or the fastest way I found to solve or to get control over the curve length. Okay. By tweaking a little bit this particular node. Okay, this is a mess, but I would prefer to stay with the P-spline because for me it looks smoother, looks nice. Nice. Can you make the Houdini file available so we can keep up in Maya from this point on? Yes, we share a link for all the files. I share with you, I mean, there's a link where I shared all the Houdini files, all the Maya files, and some reference picture as well. So please double check the link, please. So let's go to Maya. Let's go to Maya. Let's go to Maya. Here. Great. Okay, this is my, shouldn't be here. Right. Okay, I hope some of you know more or less how Maya works. So basically the way I work here, just for those who are not very familiar with Maya, the way to orbit here is by pressing Alt, left click. The right click is for activating the tool menu bar. Then, and what else? With a wheel mouse, you can zoom in, zoom out, and panning by pressing Alt and the mouse wheel. Simple as that. So what I will do here, I will be importing all my models by going into import. Let's select. Oh, let's try to select everything. Oh, I cannot do it. Okay, let's select one by one. I select my layer 1. I press F just to see if this is working fine. That's pretty cool. That's pretty cool. I will select the shadows and the anti-aliasing just to see it clear. And probably I will scale them up 10 times. Yeah, that's better. That's better. I will import them, layer 2, and I will repeat this process. I will try to do it this quickly, as I really want to explain a little bit about theory about Arnold. And let's import. The reason why I export the base mesh, it's just because we tweak them, we tweak it, we make it bigger, then we change a little bit the general shape. That's why I decided to export it. Great. It's looking great. So first of all, let's save our file. By the way, here in Maya, you can also save your file by using the project menu. Okay, just as I am just going to use Maya for rendering, I will save the simple zine inside my webinar file. Great. How to start here in Maya? First of all, we need to be mindful about several things. First of all, we need to be mindful about what kind of light we want to use. Then we need to be mindful about the atmosphere we want to create. So basically, I'm talking about the background. As you may see here, I just use a very simple black background to highlight the contrast of the picture. Okay, so we're going to create those materials. But first of all, the most important thing here is to be mindful about the type of light we will start using in Maya. As you may see here, in Maya, we have the rendering tab and the Arnold tab. We used to use those particular commands here in Maya before Autodesk bought Arnold. So here in Arnold, we have very particular light types. However, we can use them. We can use those particular light types as well. There's no difference. But let's agree on something. We are going to use just commands from Arnold. Okay, to start with using Arnold, what I really suggest you to use, instead of playing with area lights, let's go directly to the sky dome light. Okay, the sky dome light will give me the possibility to start playing with HDRIs. Okay, so if you have the HDRI in hand, you can start playing with it, because by default, this particular node will emit lights from 360 degrees. Okay, so if we use by default this particular node, we won't see any kind of shadow here, or so we won't be able to see details. So we need, if we want to create an atmosphere here, we need to start experimenting with HDRI different types of HDRIs. Okay, so what I will do is I will select my SkyDOM here. I will go to the tab here in the SkyDOM in the attribute editor, and I will go to the color, because here is where I'm going to put to place the HDRI, right? So I will go to the checkbox here next to it. And now from here, we have the possibility to choose what kind of node we want to work with. Here we have the possibility to use nodes, native nodes from Maya and from Arnold as well. Okay. So either way, that's not a problem. I will use this node that it's called file. Now we have the possibility to choose my HDRI. I have one here in my desktop. I will use this one. Okay, this is the one that I normally use when I want to test my models. Feel free to use whatever HDRI you have. I don't remember if I share this particular file with you, but let me know if you don't find on the share folder, please, so I can upload it at the end of the session or during the break. So that's nice. Let's save the file. So if I go to Arnold and I press Open Arnold Render View just to test it, let's see what happened. Let's see if this is running. Yeah, it's working. It's working fine. If you don't want to use this window, what you can do, you can change to the render standard. And what you can do here, it's you can go to the split view here. Then here I will press spacebar, Maya, perspective view, just to have the similar perspective. And in the second one, I go to render, and instead of using the viewport 2.0, I use Arnold. This window appeared, you just press play, and our model will start rendering in real time. That's what I normally do when I start testing some things in Arnold. Great, but I don't have any kind of material. Okay, so the next thing is to start creating some materials. However, be mindful about something. Let's talk about, come on, why I don't know why this is, okay, let's change it to more, that's nice. Okay, I really suggest you, if you are going to work with Arnold, I really suggest you to start using a pretty decent GPU instead of a CPU, okay? But for a base explanation, I will stay in CPU for now, but for later for my final testings, I will be using GPU. The reason why I choose CPU for now, it's because I want to explain you something about sampling. Okay, I shared with you some links in the share folder about, let me show you very quickly. I have them here. Let me see. Yeah, I share with you this particular file in where you will find some links for Arnold. So I really suggest you to go to the sample link, this one. It's because I really suggest you to read this technical part, because this will help you a very clear idea about what each sample here means. Okay, so depending of what kind of material we're going to use, we need to tweak them. So, but in summary, basically, the camera AA stands for the general resolution of the picture. So if we don't want to have a grainy picture, so let's go to IPR. I will set this smaller. Here in the common tab, I will use a square format, but I will reduce the general size, 500 by 500. I think that's enough. I will increase a little bit the resolution. So when I go to Arnold and I press the IPR, I will see this picture slower. Okay, if I press play here, okay, I will have the possibility to see whatever is happening here. Okay, for now, this is running with CPU. First of all, what I want to do is I will disable the background preview. So if you select the SkyDOM, you can go to Attribute Editor, go down here to Camera, press 0, and boom, that's better. Okay, by default, I don't have any kind of Arnold material applied here. So the best way to start creating materials, it's by right-clicking on it, on each one of the meshes, go to assign new material. And from this part, by default, I will be using Arnold shaders, okay? We can use Maya shaders as well. But for this particular webinar, we are going to use just the Arnold shaders, okay? So for now, I will be pressing the standard surface here. If we press play, something will happen. That's nice. So by default, we are using a white color. Okay, this one. I will try to apply different materials here very quickly to explain all the sample types here in Arnold. So this will be number 2. I will call this layer 1. This will be called general mesh. This was layer 4. Okay, let's put mask 1. This will be called mask 2. Let's apply a new material here. Arnold shader standard surface. Layer 2. Those names are important because we are going to create materials in the hypershade in the nodal network with nodes here in Arnold. So I really suggest you to put names on every one of these shaders. Nice. Okay. Good thing about Arnold, you can select any kind of mesh here. And here in the tab for material, you can use presets if you prefer. So let's use some presets to explain the shading part. Here I will use a chrome material. Here I will use maybe, let's select a copper material here. And here I will select a glass material, a frosted glass material. That's nice. Cool. I will change this color just to explain this part. Okay, that's more or less what we have here. I will save my file. Okay. So what about the Arnold render engine? Here, when we work by default with CPU, we have the possibility to tweak those particular values. The most important value here, the most important attribute here is the camera AA sample. AA stands for anti-aliasing. So basically, this particular input will give me the possibility to control how noisy or how grainy my picture is. So even if I reduce those values to 0, probably we won't see too much difference on our general picture. However, if I reduce the camera AA sample, let's reduce it to 0, our picture will start getting noise. So that means if I want to reduce the amount of noise of my picture, I need to increase the AA sample. Okay. But be mindful, because whatever is happening here in the AA sample, let's put it into this. Let's imagine that this is my camera and this is my object here. Okay. What it does is this controls the amount of rays we are emitting from the source, but this amount of rays increase exponentially. So that means if I set this value in 1, if I said I want to use 1 AA sample, so the amount of rays that are emitted or that are traced from the origin, it's equals to 1 squared. Okay. If I change this to 2, the amount of rays will be 4. 3 equals 9, and so on. So this value starts increasing exponentially. So be mindful about it, because that means that if you are using 6 samples, there is a lot of difference between 6 and 7. Okay. And it will increase a lot your time, your rendering time. So keep that in mind. So for me, if you're using CPU, using 5 or 6 samples, I think it's more than enough. It's more than enough. If you're using GPU, it's quite a bit different. The logic is quite a bit different, but let's keep into 3. Okay, so what about the next? What about diffuse, specular, transmission, and the rest? Diffuse calculates the bouncing light. I mean, it controls the global illumination. So in Xamarin, it controls the quality of the shadows and the quality of the indirect light. If you have it in 0, we won't calculate any kind of shadow, any kind of global illumination. I mean, this is a secondary light type. Okay, so if I put it into 1, probably we won't see nothing here. However, if we go to the AOVs and we activate, let's see the diffuse, let's activate those 3 maps, diffuse, direct, and indirect. And let's select the indirect light. Nice. If we have the diffuse sample off, like this one, we won't have the possibility to see anything inside our indirect light or in our indirect diffuse map. However, if I put this into 1, we will start seeing something. Something is happening here. Let's see if I can see it from the front. Okay, let's do something. Let's add a new light in front of it just to see what's happening here. I will go to Arno, area lights. I will press W to move this particular mesh. Sorry, area light. I will increase it by pressing R. I will move it with W. I will change the general shape disk. To a shape disk. That's nice. However, now I need to play with the amount of this light. Probably 1 is too low. Let's go to 10. Okay, no, let's go to 100. Okay, that's better. Let's put it in front of it. And I will increase the samples. By increasing the samples of a light, we are saying it's basically, we are getting a better light quality. Just simple as that. Here I will select quite cold light, something like that. That's enough. So let's go to the indirect light. Okay, I cannot see anything as well. That's weird. Well, but something is happening here. Something starts happening here. But basically what this is calculating, it's calculating the indirect light quality or the shadow quality as well. So if we want to have a pretty good results with the indirect light, we need to increase the diffuse samples. Okay. So at the end, we will have a better shadow quality. Specular. Specular treats the bouncing light for reflective materials. So basically, if we're going to use metallic materials, if we don't have this particular sample on, we won't calculate those particular reflected lights due to the reflective materials. So if I increase this value, we will get better results basically on metallic materials. Let's see if I go to 0. Probably we won't see too much difference for now, but this controls the quality of the reflective of the reflected light due to the reflective materials. Okay. Transmission will let me control whatever is happening with light when light passes through a material. So that means how we can control how the light goes through, for example, a glass material. That's why remember that we place a glass material up, at the front of this particular model, but we cannot see it. It's because my transition sample is 0. Once I press 1, the light that goes through the material will be calculated right now. If we want to increase that quality of light, we need to increase this particular sample. Okay. If by increasing this value, we see that our final mesh is still noisy or grainy, that means that I need to increase the AA sample to 4, for example. Volume indirect is for where you are going to render volumes, not surfaces, but volumes. And SSS is basically for a very particular type of material that let me control the light inside a particular a mesh. So, for example, if you look for SSS on the web, for example, here, if you look, SSS stands for subsurface scattering. If you look for this particular text here, yeah, that's the first thing you will find. Okay, it's because that particular sample controls the quality of this particular effect in where we have a mesh that it's supposed to have different attributes inside it, like density, for example. So in the case of the skin, that's why this particular sample is used mostly when we are going to create skin materials. In the case of the skin material, we have different attributes on the same mesh. So for example, at the borders, we have less density. In the middle, we have more density, and the light bounces differently inside the material. Okay, with the SSS sample, we control that. But it requires us to create a particular shader for that. Okay, that's basically what we want to do right now. That's basically we need to know everything we need to know about the samples in Arnold. Okay, so for now, what I'm going to do is I will use the GPU, render. Okay, so I will stop it. I will use the GPU as this is faster for me. But again, this depends on your graphic type. Okay. In my particular case, it's better for me to start using the GPU instead of the CPU. Got it? So, but before start doing any kind of rendering here with the GPU, there is one more thing we need to do. We need to go to the Arnold tab here, utilities, and pre-populate GPU cache. This is extremely important as this will help me to prepare my graphic card with the materials, lights, and general shaders before start rendering. If we don't do it, our render engine will run without any problem. However, it will be slower. Okay, by doing this, we're preparing our card, and now the render will be faster. Now, if I press play, this will run immediately. Okay. So next thing, what I'm going to do is I'm going to create my cameras here. Okay. I will stop this for now. And the way to create a camera. For this particular model, I remember I used a camera at the side like this. Let's try to create a kind of the same perspective here. So what I will do here is let's go to view and put create camera from view. Simple as that. And here, let's change the name. Let's put it side. To be sure that this particular camera is activated, let's go to panels, perspective, side. So now, whatever I'm doing here, is I'm tweaking the position of the side camera. So I will change this to perspective just to see the position of my camera here. That's nice. So what I will do now is I will place my camera using the attribute editor. So here, first of all, I want to put my camera into 0, 90, that's okay, and 0. Probably here in Z should be 0, and in Y, I think that's 15, that's great. 15, that's great. So then I will try to go more or less like that, using my IPR as reference. Here, probably we won't see that camera yet. It's because we need to refresh the render. I know we will have the possibility to see this side. Nice. Let's more or less create our camera. Keeping in mind that our format is square. Or to avoid deformations of the camera, what we can do is we can go to the attribute editor, go to side shape, and increase our focal length. Let's go to 80 more or less. I think that's cool. Let's keep it like that. And that's nice. Okay, that's perfect for me. So keeping that in mind, we have the possibility to add a background here in this particular case, I won't add a background for now, maybe for the next exercise, okay? So the good thing about it is that I can lock this camera, then I can change the perspective, and I can start playing with the position of the HDRI, just to see if I can add a more dramatic light. Yeah, more or less like that. That's amazing. That's amazing. So here, maybe I can add an effect. We can add, let's add some lights, one at the front and one at the top. So maybe this front light could be blue to make it more, cooler. Maybe like it. Let's increase a little bit more. That's nice. We can reduce the spread, the angle. More or less like that, to make this front light more dramatic. And I will add another light at the top just by copying with Ctrl D, the area light. Let's put it up here. Let's select the light. Let's move it up here. Let's move it into that. I will rotate this particular light by pressing J in the keyboard to maintain this organized. So like more or less like that. Let's press play to see what happened. I don't want to use blue color, but white color. Maybe. That's nice. I think that's nice. Yeah, it's looking nice. And if you want to add more, if you want to create a more dramatic scene, let's try to think this particular process as if we are in a photographic studio, okay? Because if you start thinking in that way, you will get a clear idea about lighting position. So if you want to add a more dramatic effect of this particular model, probably it would be better to place a light behind it, you know, facing in front facing to us. So the best thing to do is let's stop it here. I will copy again this particular light, and I'll rotate it by pressing J to maintain the angle rotation. Organize. Let's put it like that, and let's press play. Probably it will add this kind of silhouette, and that's pretty nice because this add a more dramatic effect in our picture. We can, sorry. Yeah, that's good. So what we can do here, maybe we can press scale to make this bigger, and we can play with the general spread angle to control that particular silhouette. I think that's pretty nice. It's pretty nice. Great. Okay, I think now we are ready to start creating our materials. Okay. So let's create our materials now, and then let's take those are my notes. Yeah, I don't remember anything by memory. So, okay. Let's start by playing with the general layers. Okay. So I will increase a little bit my resolution just to see more details here. Let's go to the render settings, common. Let's increase this by, no, not that much. 720. That's better. Okay. But keep this in mind. When we change from CPU to GPU, we will see that our general resolution, our general image quality will change. What I mean with this is, keep in mind, we are using 4 samples in GPU to render. It render fastly, and I will take a snapshot here, and I will change this to CPU again, and I will press play. Let's wait a second until this finish, and we will see a difference between them. In summary, what will happen right now is that the general resolution made by CPU rendering will be better than the GPU. I don't know the exact reason for it, but what I know is that when we are going to work with GPU render, we need to increase the amount of AA samples. Okay, as you may see, the render is taking more time to compute. However, my final output has better resolution. Okay, let's wait a couple of seconds until this is finished to see the difference. This is really important because we usually think that we can use the same we can use the same values between CPU and GPU rendering, and it's not that true. So let's see the difference. This is GPU rendering and this is CPU. As you may see here, CPU is taking quite a bit more time to compute. However, it's giving me better resolution. But I don't want this to happen. This shouldn't happen, actually. So what I found by working with GPU, it's that at least for my particular GPU, let's reduce this. For my particular GPU, what you need to do here is if we are working with, let's imagine we are working with 4 samples and for the camera samples 4. As soon as we want to change it from GPU to GPU, we need to increase this between 4 and 5 times. That means if we want to get a very similar quality, this should be at least in 20. This is more or less the ratio I found by using CPU versus GPU. Okay, so let's use at least from 20 to maybe up 30, maybe 40, but I think 40 is too much. But 20 is a good amount of samples. So now my render will take more time to compute, but I will get a pretty decent similar result. Okay, but of course this depends a lot of your GPU power. Okay, but now it's working. Okay, so now let's work on, I will put this up here. And let's start working on the hypershade. The hypershade is this particular window in where we'll have the possibility to create a nodal representation of each material we want to create. Okay, so don't be scared about this. This is not that hard because most of the attributes we can see here are the same attributes that are stored here on the attribute editor. What I mean is if you select, for example, the general mesh, okay, we will see here, let's make this bigger. Okay, where is my, okay, that's my model. Okay, what we're going to see here is the preview of the material. We are going to see its attributes like that, but those particular attributes are the same than those here in the attribute editor. So we are seeing the same thing twice. So here in the middle, what we're going to do is we are going to create its nodal representation of this particular attribute. So it's better, for me, it's better to work this way because it will give us more control over our material. Okay, so what kind of material is this? Let's work first, before going into the base mesh, let's work with this. Let's work with this one. Okay, let's work with the copper material. This is called mask 2. So that means I need to look for material called mask 2. The way to activate the nodal representation of this material is by right-clicking on it and go to Graph Network. This is the nodal representation of it. What we are seeing here, this particular node is the main shader. Okay, this is the standard surface shader we create previously. So all the attributes we are seeing here at the right are the same we are seeing here, but as an inputs. Got it? So from here, we can start playing with, let's move it a little bit, with the material, okay? Just in case, this particular option in the material viewer, usually it's set on hardware mode. If you want to see the exact representation of the material, you need to change it from hardware to Arnold. So now we will have the possibility to see the material as it's supposed to be. So we have 2 ways to control the materials here. We can start by playing with the presets That's a good way to start. Or we can start by creating the material from scratch. Okay. So on this particular part, what I will do for this particular one, I think, if you may see here, let's see the picture here. I have a kind of metallic material in the middle. It could be, we can start playing with the gold material. Then we can create another type of material for the third and first layer. We can create them from scratch. But for now, let's try to play with the presets of Arnold. So this is very easy. As you may see here, we have the weight slider that basically gives us the control to, with this, we have the control of the amount of the base color, okay? This activates the metallic attribute of the material, not the reflection on itself. The type of reflection can be tweaked from the roughness part here. Okay. But what we can do here, let's try to put this into 25, that's okay. So a cool effect we can create from this particular preset is if we go to, let's go to thin film. There is something I really love about this particular attribute. Thin film and coat may look similar because they work as a second layer of the material. However, the difference between coat and thin film is that thin film creates a second layer. Let's put it more or less. Okay, that's great. Thin film creates a second layer over the material with the possibility to change its refraction index. And it's really cool because if we are working with a metallic material, by creating this second layer will give me the possibility to, once the light hits the material and depending of the position of my camera, we will be able to see a different tone of the color, like this one. For example, in this particular case, it's more magenta, and in this particular case, more orange. It's because of the index of refraction. Okay, we cannot do this particular effect. We cannot get this particular effect with the code attribute here, but using a thin film material attribute here. So if you change the index here, we will see that how our material tone change depending of our camera, and it depends of the camera source, the camera location, sorry, and the light source as well. So we can play with it a little bit. Oh, that's really nice. I really love this one. Simple as that. Simple as that. I will move my Hypershade. I will save this file. Please, while working with Hypershade, please try to save your file from time to time, because Hypershade used to crash Maya. And I will close this and I will go to the Arnold IPR, to this one, and I will press play. And now you will see how our metallic material change. That's nice. Okay, for now we are great. We are going well. Now let's work with the upper layer. The idea of the upper layer is to have a kind of emissive material here. But this emissive material, as you may see here, is not just a regular emissive material. This particular material reacts depending on the curvature of the model. So start working with this kind of data. It's really cool, not only in Houdini, but also in Arnold as well. We can analyze the curvature of a model, and depending of those values, for example, in Houdini, we can change shape depending of curvature, or we can apply, or we can scatter points depending of attributes or curvature, for example. And here in Arnold, we can apply different types of material depending of this same curvature. In this particular case, we decided to apply an emissive color depending of the curvature. So the way to do it, let's try to go to this one. Let's see if this is this one. Let me see. Yeah, this is the one. Okay, for now, this is working as a regular transparent material. So what I will do is I will change the preset. Let's go to a very simple one. Let's create a new one. Let's create a new one. Let's go to assign new material, Arnold shader, standard surface. This will be called emissive layer, right? Yeah, now it's simple. Great, I will save this value. Okay, now let's play with it. For now, we need to go to the hypershade again. For better control. I normally use 2 monitors for this, so please bear with me because I will try to organize my viewport here. Nice. So now I can close this particular tab. It doesn't matter. By closing those tabs, you won't lose any shader because whatever we are doing in the network view, it's been stored on the material on itself. Okay. So now I need to look for the emissive layer, which is this one. Right click, graph network. Okay. So probably first is a good thing to choose a base color. Probably like that. It's nice, maybe quite a bit metallic. But for an emissive material, it doesn't matter if this is a metallic material or not. So the way to do it, first of all, I need to extract curvature data from my model. So the way to do it, it's by using a node that is called curvature. This one, okay. So what I can do is I can link the color output to the emissive color here. Okay. For now, nothing is happening. It's because I need to start working with it. Okay. And as I'm working with the emission color here, we need to increase the value of the emissiveness. The emission, probably let's go to 1 to see if something is happening. Yeah, something starts happening here, as you can see here. Okay. Some borders start to emit light, and that's nice. It's not the color I want for now, but at least it's working. So what I want to do is to work with the convex. Yeah, that's nice. I think that's good. Let's see if by changing the radius, something happened. Yeah. By increasing the radius, we emit light from a bigger area. So let's keep it into 0.2 for now, because we need to test this material later in our final render. This particular preview, it's running with CPU. I will stop it by pressing this pause button here. I will save my file here, and I will press play. Yeah, something starts happening here. At least down here, something starts happening. If I increase the radius, okay, it's too much. Let's keep it into 0.2. It could be. Maybe we can reduce the spread a little bit. That's nice. We can increase even the multiply here to make it more emissive. What about it? Maybe we can reduce a little bit the radius, right? It's too much. Let's keep it into 0.2. That's pretty decent. That's pretty nice. And if I want to increase the quality of this particular analysis, what I can do is I can increase the samples here. Now what I have here is a better quality analysis. Okay, that's nice. We're getting there. We're getting there. What else we need to change it here? Nothing else. Oh, the color. Okay. As we see in our preview picture, the borders has a kind of yellow light. However, by default, this material, it's emitting white light. So is there a way to change it? To change it? Yes. The way to apply a color in between the curvature analysis and the emission color, it's by using the AI color correction. Just remember, I will stop this. Remember that all the nodes from Arnold, or all the Arnold nodes start with AI. Okay, just if you're wondering why AI. So what I will do here, I will connect the color here to the inputs and color here to the output. If I press play, probably nothing will change. It's because here in the color correct, I have this parameter that is called multiply. When I change the multiply, let's change it to orange, probably. We will start seeing difference in our model. Probably quite a bit more orangey. Oh, that's nice. I really like it. I really like it. Nice. That's the way to change color. And if you want to change the general color, I mean, the general color of the non-emissive material part, we can go to the base color here and start playing with it. Maybe blue, quite a bit more blue. Let's put it into blue. No, not blue. Let's put it into quite a bit gold. As this is a kind of emissive material, this could be quite a bit green. Between green and yellow, that could be great. That's nice. I really like it. Quite a bit more metallic, why not? As this is an emissive, as it's an emissive metal. That's looking great. It's looking great. Nice. As you may see here, the base mesh is reacting with light, and that's really cool. That's really cool. What else we can do here? And as you may see here, this is a very simple shader. The good thing is we can combine shaders. We can combine several shaders into just one final mix of layers and apply it to just one mesh. On this particular mesh down here, this green and goldish material. Basically, they are two main shaders that were combined to create this final one. So let's go into it. I will try to go quite a bit faster. Okay. So what can I do? Let's see. First of all, in this particular case, it's better to start from scratch. So what I will do here, I will stop my render here. I will maximize this window, right? And let's start from scratch. Here, we don't need to select any of those shaders right now because we are going to create our own from scratch. Here, we need to combine two different shaders. We need to combine a shader that will contain the metallic material, which is copper, basically. And we need another material type that will contain the green color. Then I will combine them using a mask. Okay, so we'll be designing the weight of each one of those. Okay, let's try to do it. Okay, here I will be creating two AI standard surfaces. Okay. AI standard surfaces. Nice. However, those particular nodes here, I don't need them. I need to combine them. Let's maximize this. I will combine them at the end by using a layer shader. This particular node is the one that will combine, no matter how many shaders we'll have here, we can combine as much as we want. I will grab this one. I will grab this particular shader with a mouse wheel. If you grab this shader from the mouse wheel, you can move it into the inputs. Nice. And I will do the same with the second one. I will enable it. Input 2. That should work. Let me see. It seems that it works. Oh no, it doesn't work. Okay, we can do it the other way. I can join this output to the white circle. So now I go to the other option. In here, I go to input 1. That's nice. Then I do the same. The output 2, I go to the bigger circle here, go to other, input 2. Nice. Now it's working. If I want to apply whatever is happening here to a particular mesh, I need to select this shader instead of those two, because here I'm going to create two different procedures for each one of those. But if I want to apply my final material to a mesh, I need to select this particular one, this layer shader. So what I will do, just to see if this is working, I will put a name to this particular shader. This will be called final layer 1 shader. Now I will save this file. I don't want Maya to crash. Let's look for the material up here. This one, final layer shader. So if I go to my model, I can select the first layer. It's supposed to be not that one, this one, right click, existing material, because I have it here. Final layer 1 shader. That's the one we need to work with. For now, it's completely blank. Okay, there is no data here yet. But doesn't matter. Doesn't matter. Let's create our material very quickly. Okay. On this particular part, what we need to do, we need to create two materials by using surface imperfections. Okay, so I have mine here in the desktop. No, not this one, but here. Okay, I have this particular surface imperfection. This is the map I'm using to put two layers together and to start combining weights. Okay, you can find this kind of maps over the internet, but if what I can do, I can share this link, this particular picture later to the folder at the end of this session. Okay, so what I will be doing, I will put this particular picture. Okay, this particular map, I will put it over here. There are two ways to do this. We can use a file node that could contain the texture, just this one. Then I can look for it on this icon. Or what we can do, we can go to, where's my, okay. We can grab this picture, hold it, and put it into the network. Simple as that. Simple as that. Right. So let's continue. Let's press play here just to see what's happening here. Okay, that's my material. If we want to control the general contrast, what we can do is we can grab the AI range node. I will place color output with the input. And from here, for example, we can change this maximum value. Maybe we can go to 0.3. Let's press play. If for some reason you cannot see the preview picture here, what you need to do is you need to stop the preview window and press play again. Maybe here I can even go a little bit higher like that, and I can increase this value as well. This is up to you, but those are more or less the values that I use here. And I want this particular procedure to be applied depending on a curvature, okay? Because I don't want this to be applied in the whole model, but probably just on the borders, or maybe just on the middle of the model. So I need to analyze the curvature. So what I need to do is I need to apply the AI curvature node as well. And I will be applying the radius. I will be using this particular node to change whatever is happening in radius. Okay. So if this particular map is darker, probably the radius will be lower, and that particular map will be applied, I don't know, on the borders maybe. And if this value is higher, this particular texture will be applied on the bigger areas of the model. So that's nice. But I have a problem here. The biggest problem that I have here, it's that the radius input is a numerical value. Okay, it's a float here. And whatever I am getting from this is a color. It's an RGB value. So if I try to connect, if I want to connect the color to the radius input, I won't be able to do it. So what I need to do, I need to change the data type here by using the AI color to float node here. Now I can use this output value as a radius. Nice. So now here, it's okay to work with convex. Samples 3, that's okay. Maybe we can reduce the spread a little bit. Let's try to work with the same values I use. Maybe 0.10 here. I can increase the multiply here. And this is the value I will be using. Not on the base color, but on the weight. I want it to be applied on the weight. So that means I need to convert the color into float again. Color to float. And I will put it into the base. Nice. Now it's better. So now I have the possibility to change whatever color I want. Maybe orange. That could be maybe quite a bit darker. Something like it. It could be. You can increase the metallic attributes. Nice. So anytime I have blank space, flat spaces or flat meshes, this will look completely empty. That's nice. That's nice, looking better. Okay, this is more or less the way to do a copper material with imperfections, but adding this second layer of darkness, okay, by using a map like this. So where else? We can repeat this process for the other material. Why not? However, the other material, let's try to copy it. Control C, Control V. The second material won't have the same color. Let's put it into here. Let's copy the value here into the base. I don't want the second material to be white. I want it to be green. Remember that here we have two basic materials. We have a more copperish material and a more greenish material. So now I will create the green material. So more or less, let's go to a darker blue, a darker green, sorry. Let's try to go like more or less like that. And here in the final model, we need to combine them, okay? Let's see how is this done. Probably we need to go 50-50. Yeah, more or less like that. But here we need to do some tweaking. Okay, let's go to, as I'm using the same UV mapping here, probably it's better to change the placement of one of them. So probably I can change the placement of the second. Maybe I can go to repeat twice. So it'll be bigger. Here in the range, you can change again some values. Maybe this is 1, or no, maybe this is bigger, 2.5. And maybe here, this is 0 and 0.15. Maybe I can increase it a little bit. 0.15 maybe. That's nice. Then the curvature, we can increase the samples here. Convex is okay. We can play with the spread. Let's see. No, it's too much. Yeah, let's put it into 1. I think 1 is okay. Threshold, no, threshold is okay. Bias is okay. Let's see if this is happening. This is working here. That's nice. That's nice. We are getting there. We are getting there. What else we need to do? Oh, what we can do maybe here is we can use a normal map to change some values here. So what we can do here is we can use this particular shader to create more imperfections. So what I will do here is we can tweak the normal map. We can create a normal map. So what we can do is we can create a noise, an AI noise here. This is pretty cool to start using. When we start using noises, that's very fine. Let's go to 8 here. Distortion, let's go to 0. That's enough. Let's go 0.5 here. Amplitude 1, scale 1. That's okay. That's okay. So then I can select and arrange to control the contrast. Maybe I can increase it quite a bit here. 1.4. That's enough. And my goal here is to use this particular outputs as a normal map here. So here we need to go to the geometry here, and I want to place a bump mapping here. So the way to do it is we need to use two nodes here. AI shuffle that will give me an alpha value. Then we need to convert it to float with AI color to float. And what I will do here, I will grab this color to float node with the mouse wheel, and I will place it on the bump mapping here. Nice. So that immediately will create this bump 2D map, right? Now we can see something is happening to our material. That's pretty nice. That's pretty nice. Okay, so maybe here, instead of using this as a base mesh, we can change it. Maybe it's too dark. Let's see what happened here. Oh, okay, this should be in 1. And maybe we can use this particular value on the roughness. Like it. Let's see what happened when combined it. That's great. That's perfect. So maybe we can change a little bit the shape, the weight. That's better. That's better. Okay, here my metalness should be even more. Great. That's more as what I want. That's more as what I want. So now let's apply the material to see if this is working. If for some reason this is not working, probably we need to do a little tweak here. So what I will need to do, I need to press play. And let's see if this is working. This should change the inner layer. Let's see if this doesn't work, what I will do, it's I think it's not working correctly. Yeah, I suppose that. Let's see what we can do. Let's change a little bit camera. Let's press play here just to see if this is working as it should be. It's not working that cool. So maybe it's because I didn't apply any kind of UV mapping here. So what we can do maybe it's we can solve it by going here. And before applying anything into, for example, into the base color, we can use an AI UV reaction. So what I will do with this is I will probably go a little back here. I will connect the output color to the white circle here, and I will use the projection color inputs. Yes, I will go to input here, color input. That's nice. And from here, you have the possibility to change and create a UV projection here. I normally use spherical, as this is more organic shape. And we can do this as well. UV projection. I will go one step back. Color output to the other, projection color, then color to the new input, and that's enough. Spherical. Hopefully this will change. This will help me. And I need to do it again with this third one. Let's see. Back here. I need to go to the latest color output to do this, because the UV projection receives ask for a color map. That's why I use the color projection here. Okay, so hopefully this will work. Fingers crossed. Is there any difference? I barely see any difference. Anyway, let's see if this is working. Let's see if by changing very quickly the mix weight, we can see any difference here. Okay, for some reason, I am not able to see anything on the first shader. Why is that? Let me see. Okay, for some reason, it's not working as it should be. It's working, but it's the scale, it's completely different. Okay. Okay, I will check this later during the break because I don't want to spend too much time on this. It's working, but maybe the scale is quite big. It's quite different. Maybe we can change it to maybe to here. Maybe half and make this bigger. Cannot see any difference for now. Okay, I will check this later. Okay, I don't know why this is not working for now. It's working, but it's not in the scale, in the proper scale. Doesn't matter. Okay. I will check during the break. I don't know why this is not working properly. Okay, let's continue. Let's continue. And finally, we have one more material to solve. Okay, let's go to the model. Let's change it to side again. Okay, so what I want to do is I can create also a detail on this flat shape, on this flat model. The proper way to do it, it's let's grab that material. This material, it's called mesh shape. So let's go to the hyper shade. Where is my mesh shade? Where's my mesh shade? Cannot see it. Oh, let's see what's the name of this material again? Oh, general mesh, sorry. It's called general mesh. Right click, graph network. And here, let's do something very quickly. What we can do here, we can add a regular noise. Why not? We can create a regular noise. So what we can do here, let's press play, let's stop it. Let's choose this base color. It's really cool. I really like it. Maybe we can go quite a bit more metallic. We can increase the roughness, reduce the IOR. That's better. That's better. So what I can do here, probably, we can start playing with noise quite a bit more. We can combine even noises. So let's grab the cell noise here. Probably it's, yeah, noise 1, additive, that's okay. Octaves 1. Probably we can increase this value a little bit. And amplitude, that's okay. Maybe we can increase the scale as well. Yeah. So what I will do, I will use this particular map to change the position of the next one, the second noise, which is this one. So what I will do, I will grab the output color and I will put into P of position. And then I will change the another one. 3.1, like in narrative 1, amplitude 1, scale. Maybe I can change it a little bit. If I cannot see any difference, I pause the preview, I press play, and that's good. So that's more or less the texture that I want to be applied as a noise map, as a normal map on my model. Okay, so the way to do it, it's now that it's ready, I will go to AI shuffle, apply the color here. Let's go back again. If I want to apply this particular material as a float value, I need to change it from color to float. Let's put it here. Come on, you can do it. Nice. And now I can apply this value probably on my metalness. Let's press play. I can apply to my metalness probably. I can apply to the specular roughness as well. Something is happening, as you may see here. And probably we can play a little bit with the projection. Why not? UV projection. Let's connect to the projection color. Let's connect again into here. And let's see if by changing this projection type, you can change the type of reflection. Okay, it's okay. Okay, that's okay. So what else? What we can do here, we can apply this value as well in the normal map, as a normal map. So let's go to geometry. Let's grab the color. Let's select the color float. Let's select the value. Let's grab this color to float. Let's apply to bound mapping. And now we need to play with the scale. Let's go to, let's see if by reducing this scale, we can reduce the general amount of, I think we need to increase it. Yeah, let's go to 10, 10, 10. And probably here, need to increase it as well. Yeah, that's more or less. Even we can increase it a little bit more. Okay, this is up to you. Just don't forget to scale them up, to scale those values up. And yeah, we're going to have a break just finishing this part. Sorry, I didn't expect this part to be that long. So let's finish it by probably changing a little bit the base color, more darker. That's the way. That's the way. Okay, that's more or less the idea. Of course, this will change depending on how much detail we got from Houdini. But for now, I think that's okay. We can even apply a curvature analysis to make some parts darker, maybe the concave parts even darker. And if we want to apply a background here, we can do it very simply by creating a flat plane here, probably like going into a plane here. Let's press play just to see how well this is working. And just grabbing this one, extruding it, something like that. Just in case you want to create a background, that's the fastest way to do it. And then pressing 3, simple as that, something like it. Then you can apply a very simple material here, Arnold shader, standard surface. And we can play with maybe color quite a bit more metallic. And while applying metallic values here, I can go then to the thin film and start applying this value to make this a little bit colorful. Even if I reduce it, I think it will be better. Let's put it more or less like more pinkish. That is nice. And I will rotate it a little bit to that. Nice. That's pretty nice. That's pretty cool. That's pretty cool. Okay, so what I will do right now, it's almost 1 p.m. here. Sorry, it was quite a bit long. Sorry. So yeah, let's take 10 minutes break. Is it okay to take 10 minutes break? So we can then focus on the final part, which is the second one. I will try not to spend too much time on this, even though we have a lot of things to talk about on this particular exercise. Okay, so what time is it? Okay, here it's 1 p.m. but 1 p.m. here. So let's take 10 minutes break. Okay, see you in 10 minutes. So I will stop sharing my screen. And okay, see you in 10 minutes. Okay, see you then. Okay, we're back. Hopefully you can hear me. Yeah, you should. Okay, let's continue. We don't have too much time, I suppose. Sorry for making the first part too long. I didn't realize the time. Okay, so for this second part, I will try to be more specific. I won't try to spend too much time explaining again the same topics that I explained in the previous exercise. So I will share my screen again. Nice. And okay, now let's focus on this second. Can everyone see my screen? Okay, if for some reason you cannot see my screen, please let me know, okay? I will continue. Okay, for this next exercise, what I will do is, first of all, I will turn my camera off. And, okay, let's do this in this way. For this particular exercise, that it's quite a bit more complex, what I will do here is I will split this work in 3 parts. Okay, so we'll be modeling the building as one entity, the landscape as a second entity, and this, let's call it path, as a third one. Okay, so we are going to treat them independently in Houdini. Okay, so we are going to learn how to combine data between geonodes, between independent geonodes. Okay, I will try to go quite a bit fast. Okay. Okay. So let's focus first on the building. Okay. Here in the building, you will see that we also have this kind of exoskeleton here. We will be using the same procedure we did for the previous exercise. So you will get it. You will get it really fast. Cool. So let's focus on the first one. Here I am in the object network. Let's create a geonode here. Let's select one. We are going to create 3 of them because we are going to focus on 3 different procedures here. So here, this call will be called, let's call it building. This second one will be called structure. And the third one will be called landscape. Landscape. Okay, so let's go to the building part. Okay, the best way to start by doing this, it's let's start from the most simple thing. Okay, to build this, to construct, to design, to model the building, we could start from a box. Simple as that. Simple as that. Let's put into button. Yeah. So the first thing I'm going to do, I will transform this particular volume until a point that more or less looks to the general shape, but more like, let's define, first of all, let's define the limits of this particular volume. So what I will be doing is, once I define the general dimension of this model, what I will do is I will be scattering points inside it, and then I will start copying randomly volumes inside with different scales until a point and I get a kind of cluster of cubes, something like it. Yeah. Then I will start reshaping this model until a point to get, and where we get this kind of abstract building that is not that abstract, by the way. So let's go. Let's continue. Okay, what I will do here, I will transform my geometry. I really suggest you to use the transform. Does this exercise work best with Houdini geometry? It's okay to import and work from other geometries. I don't know exactly what you're trying to mean with the question, Christiana, but on this particular exercise, we're going to start from scratch, from the okay. So we don't need to import anything. We are going to. There are 2 ways to work here in Houdini. We can start by importing meshes, FBX, OBJs from anywhere we want, or we can start from scratch. So in this particular exercise, I will be working directly from Houdini. Okay, so that at least that's my goal here. Without importing anything. So okay, let's continue. Here I have my transform node. I really suggest you to start using the transform node if you want to tweak the general size of your model. You can do it. You can tweak, transform, scale, rotate your based model, your base geometry here by using the default parameters here. But I prefer to maintain the first node as clean as possible, and then transform it later. Okay, so I can make so I mean, for me, this is more organized. This is the most organized way to work. Okay. So here I will extend. Let's see if I can move it. Okay, I can move it. The first thing I'm gonna do, let's use match size, because what I want to do is I want to justify my model. What happened here? No, let's put to 0. I don't want to move it. Let's use match size because I want to justify my model. I want that the bottom part aligns with the general origin. So I will go to justify Y minimum. That's cool. And then once it's justified, I can increase or translate. No, not translate, but increase the scale here. So we'll go upper like that. Let's put it to 3. That's cool. Then what do we do? I will scatter points inside the volume. Okay. If I use scatter node here, as the name suggests, oh, sorry, I forgot to save. Let's save this file right away. Let's put file number 2. Nice. If I use the scatter point, this particular node will distribute points along the surface. But on this particular case, what I need is to scatter points inside the volume, not only on the general border, on the silhouette, but on inside it. That's why on this particular case, the scatter node won't help me. Instead, I need to use the points from volume. It works more or less the same. However, this particular node will help me to scatter points inside the volume. And this is what I need to use right now. Okay. So I will change some values here from grid to tetrahedral. I will separate points a bit more. And I will break symmetry, those homogeneous points by changing seeds, changing a scale, maybe 8. I think that's great. Okay. I think that's fine. And what I want to do, I want to copy a box on each one of those points, because I need to create a general shape to have something to start working with. So what I want to do is I will use this node that is called copy to points. The copy to points node will ask for 2 things. It will require a geometry to copy, which is the geometry I want to scatter around those points, at the targets. So I will put the points here. And in this particular case, my base geometry will be the original one. So what it does is just copy 1 box on each point. Simple as that. Okay. If you want to change the seed, you just play with it. You want to change the scale, you just play with this value. However, I want this to be quite a bit more funnier. So what I want to do is I want each box to be different in size. So what I need to do is I need to change some attributes here. What kind of attributes? I need to create a scale for each one of those points. So I can store a scale value on each point. It's possible. So let's go to attribute randomize. In the previous exercise, we used this particular node to randomize color. So by default, I don't know if you can see the colors, but by default, it randomized color onto the points, but I don't want to create a random color attribute on the points. What I want to happen is I want to store a different scale value on each point. So what I need to do here, I need to change the attribute type I want to work with. Instead of CD, which belongs to color, I will go to pscale. Pscale is the attribute that it's used for scaling to create scale values on each point. With this one, what I'm doing right now, let's go to this geometry spreadsheet here in points attributes. We will see that now we have values. We just created a pscale attribute here, three-dimensionally. So those values that are stored here correspond to scale value. So that means that if I replace those points, in this case for boxes, those boxes will react to this scale value. That's why now my boxes are different in size. I can still play with it by changing seats here. This is really cool. Then I can change, for example, the type of this distribution type. So what I normally use is a custom ramp. Just to make this easier, let's put it not 0, but more or less like that. Okay, let's keep it simple. Let's not spend too much time here. Okay, I always use B-spline when I use a ramp. That's enough. So the good thing here is that if I want to explore another iteration, another output, I just go to the pscale attribute, pscale node, sorry, attribute randomize node, sorry, and just change the global seed. Simple as that. Simple as that. So that's pretty great. Let's keep it into whatever value here it's welcome. So then what I can do here, it's if I use explode nodes, I can make this particular building quite a bit bigger. Let's increase a little bit like that. It's quite a bit bigger. And I will combine everything here. Okay, I will combine all the blocks in just one, because what's happening here, it's all of those boxes are collapsing each other, are intersecting each other, and I don't want it to happen. Okay, so I will combine every one of them by doing a Boolean operation here. The Boolean operation I will be using, it's Boolean union. I will put this input in both of them. And now what I will have here is just one volume. Okay, great. I have a cleaner volume right now. Then my next step is to start deforming this particular scatter boxes using a noise. So the way to do it, it's by using an attribute bob. Here we're going to start working with an attribute bob. However, if I start using a noise to start deforming this particular geometry, we will face one big problem. As we don't have too much resolution here on this particular geometry, our final output won't have enough resolution as well. So if I want to deform my geometry, first of all, I need to increase the resolution by using a subdivision node. Okay. The problem here, if I get excited and I increase my depth like a lot, okay, doesn't look bad at all. Bad at all. However, I want to keep more or less my general volume, or at least the original one. I mean, there's too much difference between them. So what I will do is I will click on this particular box here, override increase weight attribute, and I will increase this value until a point it more or less look like the original volume. Nice. More or less like that. I mean, I really like the idea of have very small fillets like it. That's nice. And we can increase even it one more step. That's nice. So now let's go to the attribute Bob. The attribute Bob, it's a good way to replace Bex coding. I mean, if you are interested in coding in Houdini, working with Bobs is a good way to start. It's a good way to start. Okay. So here, what I'm going to do is I'm going to use a noise to transform or to change this shape. Probably I would need to increase the resolution a little more. Let's go to 6. Yeah, I think that's better. I think that's better. Okay, let's go inside it. Okay, here in the Bob attribute, when we press noise, we have tons of options to deform our geometry. The one that I will be using today, it's the unified noise. Okay, so let's reduce this one, this one, this one, this one. There is a fastest way to work with this kind of noises, just in case if you want to avoid the attribute Bob. There is another node or sub that is called mountain. Okay? This is also an attribute noise. So if you just want to explore deformations, you can use this particular node as well. Okay, this is a really good one. I think it's faster as well. So for example, here I want to work with I want to deform those values in just in the positive direction. Maybe we can use this one, the last one, the cherry set, which is more geometrical. And we can type known here, not to have too much details. And for example, we can start deforming it. We can increase the general size noise, and so on. Okay, that's fast. The good thing about this node is that fast. It's immensely fast. The only problem that I found with this is that let's imagine that I don't want this noise to be affected at the top. I don't want any noise at the top of this particular tower. So I get problems to solve that by using this particular node. That's why I need to work with attribute Bob here, because here we can also work with the city color, and I can create a mask to start deforming something based on a mask. So what I can do here, first of all, it's this particular noise, this particular unified noise, work more or less the same than the noise node, the mountain noise here. Okay, more or less the same. So what I will be doing here, I will use the displays along normal node here, because what I wanted to do is I want this node to grab the original position of the points, okay? And I wanted to use a modified version of those points, of those points values, and use it as an amount to deform my geometry. So my final geometry will be different. It will be deformed based on the amount of noise I'm applying from here. So here, let's go to the same topology. And here, what I will be doing, I will change, let's go to 0.0, 0.05. And what I want to do is I want to copy this particular value on the rest of those spaces. So what I will do, I will be copying this parameter, and pay attention to this. I will be pasting this value here, but in this way, not by pasting values, by pasting relative references. Enter. The reason why I do it in that way, it's because if I change this value will affect the rest of the boxes. Okay. In this particular case, I don't need the fourth one. Let's go to 0.5. That's great. 0.4 maybe. The offset, as its number suggests, will give us the possibility to control how the noise is moving around the geometry. So if I go like 0.2, it will move. However, I want it to move homogeneous lay. Paste references here, and I will paste references here. So if I press 0.1, everything will be updated quickly. Then what else? For now, let's keep it like that. However, it doesn't look that bad. It doesn't look that bad. But I can reduce the final scale. Let's see if I can reduce the final scale. Okay, it's not working here. So maybe I can reduce it from here. Okay, let's reduce it a little bit more. Okay, by my goal here, it's to deform this particular building at the bottom, but not at the top. I don't want this deformation at the top, or at least I want to reduce the deformation at the top. So what I need to do is I need to create a mask based on color. Remember that we used that attribute later. We used that procedure previously, but here we need to create a black and white mask. And we can do it by using the ramp node here. If I grab the ramp here and I connect the position onto the U input and the amount on the color, we more or less be able to see what's happening here, okay? Let's reduce the blur just to see what's happening here. So let's go back. Let's enter again. Okay, it's working. I thought it was not working. Okay, we can, let's see if by increasing, no, I need to reduce it. Let's reduce the frequency. But I have one problem, one big problem here. I don't want this mask to be vertical, but horizontal, okay? My goal is to reduce the amount of noise at the top. I mean, less noise at the top, more noise at the bottom. The problem that I have right now is that by placing the ramp in this direction, so by default it's working like that. So I will have noise here at the left, more noise at the left, and less noise at the right. But that's something I don't want to happen. At least I don't. I don't want to do it, at least. So a good way to solve this, because I don't know if there is a rotation node for the ramp node. So I found another way to solve this by converting this three-dimensional value into an independent value. So what I mean is, if I remember the position attribute, it's a vector attribute. I mean, it's a X, Y, and Z attribute. If I extract those values, I can extract the vertical value, the Y value. I can change it, and I can use the vertical value and put it into here. So what I mean is, I need to convert the vector into float value. Okay. By doing this, anything should happen. Yeah, because it's using the X value or the U value in this case. But if I change it and I use the second value, which is the vertical value, it will change. It will rotate. Okay, let's do it in where it will rotate the mask. So here I just need to play with this value, maybe reducing the frequency. Okay, maybe I can increase the blur. Okay, let's see if by reducing even more. Yeah, that's better. That's better. So let's reduce the blur here. Yeah. So the next problem I have here, it's I need to have the possibility to move this particular volume. I need to have the possibility to move the mask vertically. So the way to do it, let me first finish this part, because this particular noise, this particular mask starts on this plane, and I don't want it to happen. But let's remember, if I move my, let's imagine, if I move my geometry vertically, my mask will stay in the same place. So it would look like my mask is moving. I don't know if you understand what I mean, but it's a kind of perspective. I will move my model vertically, so my mask, by staying in the same place, it will look like it's moving up and down. the model. Okay. But first of all, we need to combine those values, those color values, with my displacement value. So the way to do it, it's by multiplying whatever it's happening after the noise with whatever is happening in my mask value. So those values that are black will be 0, and the values that are white will be 1. So it will affect at the end my model. So I will kill this node because I don't need it for now. So that's that. So for now, only the bottom part of the model, it's been transformed, but not the upper part. But now I need to control the whole. I need to control the whole distribution in the vertical mode. So what I will do, I will be using the CD for now to explain my point better. Let's go back. What I need to do, I need to move this particular volume vertically. If I use the transform node here, I have the possibility to move, to translate this model vertically. And as you may see, by moving vertically, my noise start working below the zip line. Okay, that's nice. However, let's put it -1. Now I'm facing another problem. I need to put this model back into the origin that it was previously here. So this is very simple to do. Let's grab a match size node here. Let's use this as an input, and let's use the original model as a reference. Nice. So what's happening now is that I can grab my transform node, I can move it, and my mask will start moving. Okay, let's put it like that. Not too much. Maybe like that. Yeah, maybe like that. Great. Great, it's working fine. It's working fine. Okay, let's continue here. I will select this node here. I don't want it to happen. Then, well, that looks nice. Looks really nice. Okay, maybe, oh, sorry, I forgot to put it here. Oh, that's nice. Now it's nice. Great. Great, we can continue here. In the file that I share with you, you will find inside this Bob node, you will find other options here that I developed, okay? Because there are other noise types you can use to transform this geometry. I am just using one of them, okay? But in the file that I shared, you will find more noise type and a switch node here. You will find a switch node here. You just need to change the parameter input, okay, to start playing with it. But for now, I will stick in this with this one. Okay. So let's continue. The first thing I need to do is I want to create my exoskeleton or the structure. So I will be using the same procedure we did for the first exercise. I will scatter points. I will transform the points. I will move the points through a curly noise, right? I will use a trail node to see every iteration in real time and convert them into volume and so on. So I will be doing this quite a bit fast. First of all, let's see if this model is clean enough. It's not. Okay, doesn't matter. Let's do a very quick BTB. Let's BTB. Let's use them convert BTB. Okay, I will use, let me see. Let's put the voxel size in 1 just for a moment. Okay, this looks like a potato. Let's put it 0.1, maybe 0.01. More than enough. More than enough. Let's use a BTB resample node. How many voxels do we have? 2.6. Let's put it into here. 2.6 million. 2.6. 2.3, that's better. Okay, let's organize it, converting it into polygon again. So now I have cleaner mesh. I mean, a mesh without collisions. If you prefer, you can add an attribute blur, or you can use here a delta mesh as well to relax the mesh a little bit. So, I mean, this is optional. You don't need to do it. But I just want to clean a little bit the mesh. You can use both of them, whatever of them. Nice. But I will stick with the attribute blur. I will save my file. Then let's go to scatter. Let's play with it. So let's imagine I want to scatter some points up here like that. And what we can do is we can follow the same logic as the noise. So if we want, we can scatter more points at the bottom than the top. So if we can do that, we need to go back to the attribute blur and we reconnect the CD attribute, because now we are going to use that attribute. Let's go back. We will see that our mesh has black color. Doesn't matter. Let's go to the scatter point here. And probably we need to change here some attributes. Instead of using density, let's see if we can use color node. No, we cannot use it, color nodes. Okay, because I lost. Okay, okay. Let me explain you something. Until this point, we used to have this this color attribute working fine, but once we start working with the BDB process, in the BDB process, we lost that particular attribute, that color attribute that I need right now. So what I can do, it's I can grab that attribute that was solved on this step. I can and then I can copy this attribute on the new mesh down here by using attribute transfer. Is it attribute transfer? I think it's attribute transfer. So attribute transfer. Yeah, I think it's attribute. Yeah, it's attribute transfer. Okay, well, so here we need to do. Here we require our geometry in where we want to transfer our attributes to, which is this one. And in the second input, I will link our reference attribute, and by default, it will copy the color. Okay. By default, our attributes are stored on the points. Here we can see that our CD attribute, which is the color, it's stored on the points. So just in case, you can go here in the attribute transfer, you can go to the point attribute here and select color, just in case. Okay, but by default, it copies the color. Nice. Now that I have transferred my CD attribute, then I can use the density attribute to scatter points based on that density. So now, as you may see here, if I increase amount of points, you will see that I will have more points at the bottom than the top. Great. That's pretty nice. Let's increase it a little bit, change it a little bit. Relax it. That's nice. Maybe I can go like 100. Yeah. Okay. So let's continue, because here I will be using the same procedure we did previously with the solver. Let's remember, we use the solver here. We use a trail here. Then we use the resample node. Then we use the smooth node. Nice. But before going into the trail part, let's go inside the solver, and we will repeat the same procedure we did in the previous exercise. So here I will grab a point bob. This point bob will contain the curly noise. If you remember well, let's press Shift S. Let's see if this is active. Yeah, this is active. Let's go inside, and here we are going to work with the curl noise. This is very simple. We will add a new value on the original value. Oh, that's what I wanted to do. And then I will connect it into the position. Something will start happening, as you may see here. That's nice. Okay, so here, before going into the solver, we need to grab our connected adjacent pieces. Let's go to adjacent points. That's nice. Let's increase the radius. More or less. Let's see. Ah, nice. That's what I wanted to happen. Let's increase a little bit more. Okay. Let's see if we can increase this one. That's nice. That's nice. So inside the solver, something will start happening here. That's great. Let's go inside. After the point bob, we need to resample. Sample the curve here. Let's reduce this to 0.5 maybe. Oh, and use it as a subdivision curve. Let's see if this works. Yeah, it's working. Oh my gosh. It's too messy. Okay, let's go back and reduce the amount of points. Okay, work now. Okay, you can play with higher values, okay, or you can play with higher scattering point values. But for now, I will try to be simple. I'll try to stay simple because it's too much here. Okay, this is getting crazy. Let's go back. Let's reduce this. Okay. Oof, that's great. Okay, let's go inside it. Let's go inside our curl noise. Let's try to change some values here because see, this is getting crazy. Here we need to go to simplex noise. Yeah. And let's change some values here. Let's change the amplitude. The amplitude is too high. That's better. That's better. We can even change the roughness, maybe 0.1. It's simpler. Yeah, that's better. And I think that's enough. Let's go back. Let's go back and let's select the sample node. I think 0.1 is okay. Let's go back and increase a little bit the amount of points. 300. Yeah, and let's increase the radius search. 7. That's nice. Anyway, let's play with other iteration. Okay, that's nice. That's perfect. So I will have smaller structure at the top. That's great. Great. That's perfect. Let's go inside the solver. Oh, don't forget, we need to connect our geometry. We can do it on any input here. I will be using the 4th one. And oh, we can randomize the color. Don't forget to randomize the color here. Let's do it. Let's do this quickly. Primitive. Yeah, let's go to 2 values. Let's use 1 here, 1.5 here. Let's go back. This is not working, probably because here I will delete some attributes. No, not delete. I will delete attributes here. So whatever we did here, I will delete color. Nice. So from here, it should work. Let's start again. Let's see if this worked. Oh, I need to reduce this to 2, but it's not working. It's not working. Let's see why it's not working. Come on. It's set correctly. Anyway, we can randomize the color later. It doesn't matter. Okay, the good thing is that it's working. So let's go to Ray. Let's grab our fourth input. Let's put it into minimum distance. And that's enough. That's great. Let's keep it into 96. That's enough. So what I will be doing here, probably, there is one node that is called time shift. Yeah, here I will put a time shift node. And this particular node sticks with the timeline here, but what I can do, so if I move my slider, my whole animation changes, but what I want is I want to stick with this particular iteration here. So what I will do is I will delete this channel, keep this in 96. So from this point onwards, anything will happen if I change my timeline. So that's great. So now let's, I don't know why I couldn't delete attribute of color here. I want to delete colors. Let's go to point attribute. No, this is for primitives, I think. Okay, I want to delete everything. No, not from here, but from here. If I want to delete everything, I can press multiply. That's nice. Okay, that's great. Let's increase some trails here. Okay, this is not working. Come on. Let's use trail again. Okay, it's working. Right. Okay, let's go to 15 maybe, not too much. And after it, I will be using attribute delete. I will try to go faster. Attribute delete here to delete the colors. I will be using, okay, it more or less happened. Ah, that's great. I needed to delete the color attribute in the primitives. That's great. Weird, but great. That's extremely weird. Okay, but it worked. That's good. Okay. Oh, we need to select here the array. Now this should work. Okay, let's keep it into 96. That's great. Let's put the time shift here. Let's put delete. Nice. It's done. Let's continue. Let's resample the curves. 0.01. Let's go to subdivision curves. Let's use smooth. Perfect. Now we have our curves, the same as the previous exercise. Let's put it into here. We have also, we have our geometry here. That's nice. That's nice. So we can continue. Let's continue. So the next thing I want to do is I will split the curves. Let's try to be simple. So here I will go to partition. Let's go to partition. Let's select our rule, split by colors. I have two colors. So I will use the blast node twice. And I will split them. One color here, the other color here. So I have those two. I can split them again, but for now I won't do it. I won't do it because I don't have too much time. Then let's do the same procedure here. Let's turn the days off. And here I will be using polywire, my polywire node. Let's connect it in here. Probably this will be a mess. That's okay. Let's reduce it. Let's click on prevent joint buckling. Probably here I need to go to normal. Let's see if this worked. Maybe later. Okay, anyway, it's not working. Anyway, what I have here, it's my polywire node, which is working fine. If let's do a very quick here. Let's add the ramp here. Let's put the same name we just previously, which is previously wire radii. Let's accept. Then let's stop a little bit just for a moment. Let's go to the wire radius, Alt-E to open this window. Let's create a ramp, ch ramp, parentheses, quotation mark for the name of the particular ramp, which is wire radii. Let's call a curve U. For now, I don't have this attribute on, so I will do it right now. If I turn this on, this won't work. It's because previously I didn't activate in the resample node the curve U attribute. Now I need to check this on. Great. That's great. So probably I need to multiply it by a smaller number. Yeah, maybe less, 0.5. Yeah, that's better. So let's play a while with this ramp. Let's make it thicker on the central part. Let's select all the nodes. And let's go to the white arrow here, this spline. That's great. Let's activate it and let's continue. That's nice. Cool. Cool. I will repeat this process for the next one as well. Come on, come on. Yep, let's connect it. And I will do the same. I will increase the general scale of the model. Just be mindful about this part. I will increase the size of this one by using the transform node. Let's turn this off. Okay, I want to increase the size, but based on the centroid of the model. So what I will be doing, I will use match size here. It will place my model on the origin. Now I can increase the size. Then I will use the match size again. I will use this like that as a reference. Turn it on. Okay. I know I can transform it from its origin, from its centroid. Sorry. No, that's better. Let's wait. That's nice. Let's put it into here. Let's organize our script. Let's see how big it is. Okay, it's too much. Doesn't matter. Let's go here, maybe 1.3. Okay. For my particular render, I use four layers, I think. So for now, we're going to stick with just 2 layers, okay? Because we don't have too much time. Let's continue. Let's continue. Okay. Okay, let's see if we have color in the primitives. Let's see if I can change the color. Yeah, let's put it into white. And the next one, let's use a greenish color, probably. Yeah, just to see the difference. Let's put it into flat shaded just to see what's happening. Nice, I have both of them. Let's see how this looks together. Let's grab the merge node. Let's select those of them. Next, we need to go up here. Up here, not that one, probably this one. Let's see if this is the one that I wanted. Yes, I think so. Yeah, that's the one I wanted. This one. So let's grab this one. Let's put it on the merge. Let's see how this looks like. Yeah, it's looking great. Okay, it's looking great. So next, I will delete attribute for the general building. Let's go back. Pressing U. Come on, you can do it. It's quite a bit of slow right now. I will delete primitive attribute. I will delete everything. By writing the asterisk symbol here, what we are saying is delete all types of attributes that are stored there. But if you prefer to delete a particular attribute, you need to look for it on next to it, like color, something like that. But sometimes I prefer to delete everything just to maintain my model clean. Great, great, great. We're on the way. We're on the way. Let's put a different color here. Let's put it a more magenta color just to see the difference. I think it's done. Yep. Okay, let's continue. Let's continue. What we are going to do now, it's we're going to combine each one of those polywires. Let's combine them with BDB from Polygon. Let's do this quickly. Then we are going to use BDB resample. We're going to do sample. Then we are going to use the BDB reshape. I think we can use it twice or maybe once, just for now once, I think. And a route option. Then we are going to go to, they're going to use convert on convert BDB. Then if I remember well, after it, we can use delta mush or attribute blur. So I will be copying this one to the next one. I will increase my voxel size for now, just to see the computational part. That's nice. Let's reduce to 0.1. No, we need to reduce even more, 0.05. Oof, even more, 0.02. But that's better. But I want to get more detail, 0.01. Probably I won't go any further. I think that's enough. Okay, let's try 0.08. Okay, in this part, be really mindful and careful of those values because this is really a really small value. So we can crash our computers. Okay, it worked pretty fine. Yeah, so that means that here I need to use the same value, 0.005. Connected it. Let's wait a second. This usually takes time, but that's completely normal. Let's see the resampling part. It's okay. Okay, maybe the eroding part, it's too much. Convert to polygon here. Polygon, delta mush, just to clean a little bit. Yeah, I love this kind of details up here. So I will increase this value to make this smoother. That's perfect. For now, let's keep it like that. Okay. If we want to get more detail on it, I would reduce this particular value. Let's try just once, because this particular process usually takes a lot of time to compute. Okay. Let's wait a second, please. Bear with me, please. I will drink my water. Now that's the point. Yeah, now that's better. That's better. Yeah, that's better. That's what we wanted to do. Okay, not sure if I should go that way to the other one. Let's do it. Let's wait, let's wait. Then we need to clean the model by reducing the amount of polygons. So let's wait a little bit. Is it okay? It's great. What happened here? I didn't see any difference. What happened here? Let's wait a second. Let's see if this is working. Yeah, it's working now. Oh, okay, because I forgot to change it to polygon. Sorry, my bad. Let's wait a second and let's continue. Okay, the next thing is to apply. We can apply color here, or let's do it into Maya at the end, because we can create a color texture here on Houdini, and we can export that on Maya. However, but the only way to do it is by exporting FBX, but I'm not sure if we can export. I don't think we can export FBX on the apprentice version. So let's try to create a material on Maya. Let's save the file. How many polygons do we have? It's like a lot. So I will poly reduce it. How many polys? 8 million is too much. Let's reduce it to 10%. And here we have 4 million. Let's reduce it to 15%. Let's connect it into here and into here, and let's wait. This is the only part that takes a lot of time to compute, but it's better to reduce the amount of points if we are going to render in Maya. We can export this high poly mesh into Maya, but there is a high chance that our GPU will crash before it starts the render. That's why it's better to poly reduce the model from here. We can use also the remesh node. There is another node that it's called remesh. Oh my gosh, that's huge. The remesh node. The only issue is that remesh usually takes quite a bit more time to compute. That's why I decided to use the poly reduce for now. Well, let's see. Let's see if that worked. Okay, it's analyzing the other one. Okay, let's wait a second, please, until this finish. We're going to do this only once, okay? We're not going to play again with this value. Okay, let's see if someone has questions. Okay, the link was shared. It was shared. Okay. Probably at the end of the session, I will add more. These particular files, I will be adding these files at the end on the same link of the same Dropbox link, just if you want to go through it. Come on, you can do it. Let's wait, please. Come on. Almost there, almost there. Then in the Maya part, I will try to do it faster because we don't have too much time. Almost done. It's preparing, and that's nice. Reduce it. Yeah, reduced. Nice. Great, great. That's the point. So we can merge them just to see how this looks like with same node here. Great. That's nice. Okay, let's continue with another part. On this render, you will see that the general building, it's split in several parts, because here, for example, I have one material, and here I have another material. So I need to split the volume. So what I will be doing is I will analyze the curve of my geometry, the same procedure we did in Arnold. We're going to do it here in Houdini. We're going to analyze the curvature of the model to extract a piece of the model depending on the curvature. Okay, I will do this quickly because there are some parts that are missing. So let's go to the next part. Let's save my file. And for this one, I need to work with the BDB model, but this one, yes. Then I need to convert them into polygon. That's nice. And from here, I will grab a null just to maintain this in order. Okay. So what I need to do here, I will analyze the curvature of my model. There are two ways to do it. We can use the node. We can use this one, the measure curvature, and there's another node that is called measure. This one. We can use either, both of them. In my particular case, I will be using the measure curvature. Then, okay, let's work with the concavity. I will reduce this value, as you may see here. So this particular attribute, this particular node creates an attribute that is called concavity and convexity. So I'll be focusing on the concavity attribute. There are basically those values down here, and that's nice. So those values, I will be using those values to split the geometry depending on that particular attribute. Maybe I can even reduce it a little more, like that. Yeah. And if we prefer, we can go to the color node, maybe. No, not that one. We can go to the color node to increase the resolution of that particular color. We go here, we go to run from attribute, we can select the concavity, and with here we can increase the color, the contrast a little bit. And then what we can do here, we can use an attribute blur to blur the color. Okay, that's better. Okay. So next, what's next? So I need to group this particular model in two pieces, the ones that are white and the ones that are black. So the way to do it, it's by using the node cluster points. I will be using cluster points. By default, this works depending on the position. So this will happen by default. But I don't want to use the position attribute, but the color attribute that I previously set. So that's more or less what's happening. However, I don't want two clusters, but just two. That's what, that's perfect. So it's dividing, it's grouping my geometry, in this case, depending on the concavity of the geometry. And that's pretty fine. If I decrease the blur attribute, in consequence, this particular group will be smaller. If I increase the attribute blur, it will increase the part. But I need to clean all the edges. So the way to do it, it's once I cluster the points, I need to transfer whatever attributes are on the points onto the primitives, because I want to grab, what I need to do here is I need to grab all the borders and clean the borders. If not, I will have this kind of steppy edges, and I don't want to have it. I need to have all those lines cleaner. So I need to transfer the attributes from the points to the primitives, so then I will have the possibility to grab the edges. How did I do that? It's by going, first I need to transfer some attributes, I need to promote attributes here. So I need to use attribute promote. I will promote from points to primitive. I will promote the color, right? Now you see the difference, and I will select a type of promotion. You can select whatever you want. I normally work with mode. So now it's cleaner, as you may see here. With that said, I will go to group by attribute from attribute boundary. This will help me to grab all the borders. So let's go here onto cluster points. Yeah, so here I need to select. Here I need edges primitive. That's okay. However, I need to group depending on not the UVs but the cluster. Yeah, that's nice. And then we can use a smooth or edge smooth. Sorry. And with this node, let's wait. Let's wait. Okay, here we need to select the group. The group, it's called group from attribute boundary. This is the group that I already created. This will select all the borders. And I can start cleaning up all the borders. Yeah, that was clean. However, I have a double line here. Probably it's because let's go to the clustering part. No, let's go to attribute promote. Let's go to minimum. There are a few colors here. Okay, that doesn't matter. Anyway, for me, that's perfect. For me, that's perfect. Looks really cool. So then I will increase my edge smoothing strength, like 2000. Why not? Filter quality 2 is that it's okay. Maybe I can increase this relaxation attribute here. Maybe let's go to 500. This will smooth whatever is it's near to the edges. Okay. Well, we can do it like that. 25. That's better. That's better. Okay, so now what I can do now is I can split those particular groups. It's supposed that they are just two. Yeah, they are two. So what I will be doing is I will use the blast node twice, one here, one here. And then let's see. Save the file. And from here, I need to call a cluster. Here I create some clusters that I need to call this particular attribute to split them. So the way to do it, it's by using here this logic. I will call the add letter is for calling an attribute. I will call the cluster equals the first group. Okay. This will erase the first group. Okay, there's nothing in the first group. Let's see the number 1. I don't know why it's not splitting. For some reason, it's not splitting my model. Why is that? Why is that? That's weird. Let's see if I made a mistake here. Everything looks fine. I don't see any problem here. Cluster, that's okay. For some reason, this body doesn't want to split my model. Let's do it again. Using the blast node again. I will try to do it again. Blast node equals 0. But it's not splitting the correct way. Okay, we can keep it. Doesn't matter. We can keep it like that. For some reason, it's not splitting my model. Anyway, we can what I can do is I can you can export it my model as it is. Doesn't matter. We need to continue. It's weird. The reason why it's not working, I don't understand. Anyway, I can use that attribute then in Maya as well. What we can do here, maybe we can change some colors. Well, let's grab that color as it is. What we can do is we can export this particular model and try to apply different textures depending on the color in Maya. Let's try to do it then. I don't know why I cannot split them right now. But anyway, let's continue. Let's find a solution later. Here's my model. Yeah, I will replace this one for this one. Great. So this is more or less what I have at first. Okay. That's Mayan. That's Mayan. What we can do here, if I start playing with my timeline, probably I will lose part of my simulation. So what I can do is I can bake my model here. There's two ways of baking a model here. One of the things we can do is we can use the stash node, to store data here. So if I go to stash node and I turn it on and stash the input, then I can kill this process. And doesn't matter what I do previously. From here, I will have all the model baked into here. The only problem that I found with this particular node is that when I start saving, it takes more time for the computer to save the file, as I have here my whole model in this node. So what I prefer to do here, instead of using the stash node, I will be using the file node here, the file node. So here I will go to the desktop computer and I will put a name to my file. This will be called building.bgo. Okay, that's the way. Split accept. Let's connect this file. Let's connect my file here. And instead of read the file, let's put write file. This will save a copy on my computer. Let's go to the webinar here. Where is my file? This is the file, building BGO. So now I can reference this file from the computer, read file, and that's enough. So this will save faster. Cool. Let's continue. Let's use the transform node for now, just in case, and let's put a null input as an output. Let's call it output 1. Okay. Simple as that. So let's continue. Let's continue. I have my built-in here. Let's save the file. Let's check the model. More or less, we have the model. So what I'm going to work right now, it's the structure that is below the model. Let's try to do this quickly. Okay, let's go to the structure here. What I will be using, I will create a box, because right now what I wanted to do here, I want to simulate some kind of roots below the building. So here what I need to do is I need to move again points depending on the noise. So the best way I found to do it without simulation, it's to create, what I'm going to do here, what I'm going to do is I'm going to create a kind of virtual volume, which is going to be a limit. Okay. And then I'm going to scatter points at the top of this box. And based on a curly noise, I will move those points around this volume without simulating it. Okay, without simulating it. So let's do it faster. Okay. Okay, let's keep this box simple. I will use a transform node here. Just in case, if you don't want to see the previous model, select on this particular icon. Let's go to hide objects, and that's enough. Then I will group the upper face of the box. So the way to do it, it's by going into keep by normals. I want to keep just the upper face of the box. I will select, in this case, I need to select Y direction and reduce the spread angle. Then so I can keep just the upper face. Then I can scatter points depending on a group. Oh no, not this one. It's group. Sorry, group 1. That's the one. Okay, so I can scatter points at the top of the cube. Let's reduce the amount of points like that. Okay, now Let's do a match size, just in case. Because what I wanted to do here, I want to increase the size of this box. But I wanted to increase the size, justifying by the, not the minimum, but the maximum, yeah, to negative. Yeah, that's nice. So here, I will increase this value. Let's increase it like a lot. Let's put it like 11. I will copy this value, copy parameter. I will paste it into here. Nice. And I will using the same value here, but divided by 10. Yeah, so if I change this value, I will keep the same ratio. Great. That's nice. So let's continue here. Then I have my match size. And so just in case, let's grab another transform node here, because here I just want to increase the general scale of the volume. So probably here I will go like 3, 3, 3. I need it to be really, really big. Okay, because this particular box will be the limit of my actual roots. Okay. So let's continue. Let's continue. So now I need to create a volume. I need to create a volume that will contain a velocity attribute. So that velocity attribute will help me to move points inside that particular box. The way to do it, let's do it quickly. I will use a volume node here, and I will create an attribute that is called velocity. Vel is for velocity, and it's a vector. I will connect that one, and that shouldn't be that flat. Let's see if I can visualize the volume, visualization here. Okay, let's see why. Okay, because I need to increase the resolution of the box. That's why. Okay, probably if you want, we can increase the scale a little bit more. Yeah, something like that. Maybe like 5, maybe, or 6. Okay, those are the limits for my for the roots. Okay, for the curves that is going to work as my roots. Those points here will move inside. Where are my points here? Those points that are here will use those limits to move them inside it, something like it. So now that I have this volume here, I need to store a noise attribute in order it to move. So that means that I need to use a bob. But in this case, a volume bob, because I'm working with a volume. So let's go inside it. Okay, for now, I won't be using the density attribute as an output, because I need to store data on the velocity attribute. So that means, first of all, I will be using the curl noise here, and I will be using the position here. That's great. Let's play with the analytic purling noise. Let's reduce this by 0.36. Here you just need to play with the values. Let's paste. Let's paste. And let's do not play with the offset. Let's reduce the amplitude, maybe even more. Roughness, it's okay. And then I need to store those new values on the velocity attribute. So from here, I can create a new attribute by using the bind export. By using the bind export, what I can say it's whatever value the curl noise is creating, please store them in a particular attribute that I want. What kind of attribute? The velocity. Okay. That's the way to send data to a very particular attribute. This velocity attribute is not a float, it's a vector. So I need to change its type to vector. So if we did everything correctly, we can use the volume trail, and hopefully this will work. Let's connect the points here and the trail here. And we need to set the trail length. Let's see if this is working. Let's reduce this amount, this value, and let's increase steps. Okay, it's not working. Let's see why it's not working. I can see something here, but it's not working. Let's try to see why it's not working. This used to happen. This usually happens. Let's see if by increasing the size of, okay, something's happening here. I needed to increase the general size of my box. Okay. So probably I need to increase. Let's see, let's increase this vertical size. Let's reduce. No, I need to, let's see. Okay, something's happening here. Let's see if by reducing this, it will increase my, yeah, something's happening here. Probably need to reduce this value as well. Okay, let's wait. Okay, I like this. I like this one. That's really cool. Nice. We made it. We made it. I think that's the best way to create this kind of trails without simulating anything. So it doesn't matter if I move my timeline, it will stay the same. I can change the amount of points to add more detail on the trails. We can change the general seat. Maybe we can separate points here. That's nice. And what else we can do here? Let's see if we can go inside this volume. Curl noise. Let's see if by reducing the frequency, we can get better results. Not too much, something like that. Maybe I can reduce the roughness. That's better. Okay, I really like it. That's really cool. Okay, let's keep it like that. Let's keep it like that. Let's not invest too much time on it. Okay, those are my trails. Looks really cool. Next step, resample node here. I will resample all the curves. Let's see how many points we have. It's a lot. Let's reduce it. I mean, let's go to subdivision. I think that's okay. Let's use a smooth. Let's increase this smooth of the curve. Doesn't change too much. I think that's nice. So now we can use the polywire nodes. However, I have them. We have a polywire node here, the one we tweaked. Where is my polywire node here? This one. We can copy it. We can paste it here. Okay, we need to increase this value. It's not a problem. Let's go to Control E. Let's put it 1. Let's play. Let's press play. 2. Let's go to 3. It's better. So maybe what we can do is we can increase those particular values. Those are, we can put it into, which value do we have here? We can increase this value to 2. Let's see. Okay, that's better. It's better, but I need to turn it on. Oh, okay, I know why this was not working. Okay, let's go to 0.1. Why? 2. Okay, that looks better. That looks better. Accept. Let's continue. Let's continue. For those who are asking, all the files are on the Dropbox folder. Okay, I'm following the exact same procedure, but I'm changing some basic parameters here. So At the end of the workshop, I will be sharing these files as well, so you can compare them, right? So no worries, don't worry about it. And probably on the files that I shared previously, you probably, if you go to some Bob's notes, for example, here in the previous one, and this particular, where, for example, in this particular note here in the building part, you probably will find that here there are more noise types, for example, nodes, so you can start experimenting with them. I just focus on just one of them, but the general procedure is the exact same. There is no much difference, so no worries about it. I will share this anyway. Let's continue. Let's continue. PDB from polygons. I will combine them in just one root. Let's go to 0.1, maybe quite a bit less, 0.01. I would go lower. Should I? 0.01. Okay, I think no more than that. Yeah, I think 0.01, it's more than enough. Oh my gosh, it's too slow. Oh, it's too much. No, it's too much. Yeah, let's keep it simple. Okay, let's keep it simple. Let's keep it simple. I will use very sample PDB. Hopefully this won't take too much time. Nice, nice. And let's go to the convert PDB. Probably in the file that I shared with you, you will see that all my BDB processes are longer, because I usually use delayed and erosion to have more control on the final output. But for now, I will just be simple here. And finally, let's use the delta mush to clean this up. Let's go to 50. Let's go to 75 maybe. Oh, that's better. That's cleaner. Let's save the file. How many faces do we have? 6 million. Oh my gosh, it's like a lot. Okay, I need to poly reduce this. Okay. Reduce, or there is another way to do it by going into the convert BDB, and here we can tweak. We can play with the adaptivity. Let's try to see if we can go to 0.01. Yeah, more or less. Even though we'll lose our general resolution, but I think that's a good solution. 2 million. That's great. That's great. Okay, let's keep it like that. Let's keep it like that. 2 million. So here I can reduce it to 30%. This will be faster. Don't forget, if you want to avoid this process of waiting the poly reduce node to work in the convert BDB, just tweak the adaptivity, the adaptivity parameter. Let's put it like that. If you want to avoid this process, I will put it here, clock. If you want to avoid this process, you can go to the adaptivity part here and change it from 0 to a very small number. If you go to like 0.01, that's more than enough. If you increase this value, you will reduce the amount of final polygons here. But the problem here is that probably you will start losing resolution. Okay, try to experiment with it. How many polygons? Yeah, that's better. I think we can even reduce a little bit more. Yeah. Okay, let's keep it like that. It's not that bad. Cool. Cool. What else we need to have? Oh yeah, I was forgetting. In our render, as you may see here, we have like these small bubbles, glowing bubbles at the top of the curves. The way to do it, the way to model them, it's by going back to the curves. Yeah, here, and I will need to select the end point of each curve. Yeah, not the beginning, but the end point. So a good way to do it, it's by grouping by expression. By grouping by expression. So let's use the smooth curve instead of the resample. So here we have some options, some presets for VEX. So you don't need to code. You don't need to code from scratch here. If we go to the first point of primitive, now let's go to point. Yeah. If we select the first point here, first point of primitive, it will select all the points that correspond to the origin. However, I want to select the end of the points, not the beginning. So let me see my note because I have everything noted here. Okay, the best way to do it here, it's instead of saying 0, we need to add here a btx -1. So it will select the other way. That's perfect. I remember when I asked this question to the forum, people used to give me a lot of different answers for this. So the way that I'm showing to you is the easiest way I found, the easiest. So that's great, because now what I want to do is I will grab a sphere here, and I will place this sphere in each one of those points by simply copy the point. I will copy this geometry onto these points. Let's wait a second. Oh, sorry, I need to put it here that my target points are group 1. Nice. However, this is too big. No worries. Here I will be going to attribute randomize. I will randomize, not, okay, let's randomize the color. Why not? Yeah, let's randomize the colors. I don't mind. And let's randomize scale of each point here by setting p scale. Going to ramp and playing with the values here. Maybe here's too much. Yeah, more or less like that. And that's nice. Now I can merge them. Value reduce and the merge. Quite a bit big, probably. Let's decrease the scale by using a transform node. I always prefer to use a transform node to reduce the size. Nice. That's great. That's great. And for now, I will be using, okay, that's the merge. That's pretty fine. Here I will be using this one as a new output. Let's put a null here, and let's call this output 2. Great. So what I have right now is, let's see. No. Not this button. This one. Yeah. So what I have here, it's my building. And this building is, it's moved. Oh, it's moved this building. Let's see. Let me see my points here. Oh yeah, they are there. I know why it's moved. Anyway. Okay. Okay, let's go back here. Let's select the output. Now I have my building. I have its roots, but it's really moved. And finally, I need to finish with my landscape. This is really big, but I can reduce the size. I can reduce the size later. So for the landscape, for this particular landscape, I need to import whatever was happening with the roots. I need to import it into this new geometry node. So the way to do it, it's by using the object merge. Okay, let's clean this. By using the object merge, what I can do is I can look for my previous output that it was in the structure part, output 2, and this will import my model again. Okay. I usually do this when I work with several models inside the same file, just to keep the order. So I know what the building is, I know what the structure workflow is, and the landscape in this case. So let's see if I can move, if I can reduce the size of this particular. Let's make it smaller. Let's go to, I will transform it. at the end. I can do this from the beginning, but I would prefer to do this very quickly. Because there is no much time. We don't have too much time, so I need to finish it with the rendering part. That's why I need to run. Okay, probably I need to, I will move it by using the gizmo here. Wait a minute, like that. I think that's better. Yeah, very nice. Okay, let's continue. Okay. Here I need to create some platforms, as you may see here, but these particular platforms depend on the general structure. So I will scale them. I will scale these particular roots to 0 to start working those flat islands. Okay, the way to do it, the fastest way to do it. Okay, I will use the transform node here, and I will scale this to 0. Okay, so it looks like this. So I will convert this particular flat object into volume. So the fastest way to do it is by using the ISO offset attribute here. So let me see the values that I use for this particular process here, because by default it won't work. I need to set this as ISO surface minimum here. Let's see if we can grab a value here. Okay, it's not working. Probably I need to increase this value as well. Hopefully this will work. Okay, it's not working. Let me see why it's not working. Let me see if by reducing this value. Okay, I can see something. Okay. I see something here. But it's not a volume. Okay, probably. What if I reduce this value? Okay, it's not working anymore. Okay, I found it. Yeah, we need to find the proper offset value here. Let's see if by increasing this value, I can get a little bit more. Yeah, 3. Okay, maybe 3. Okay, let's keep it into 3. Okay, then I will, let's use an attribute blur to clean it a little bit. I will increase the position. Yes, like that. That's perfect. Okay, this is the shape that I will be using to split, to create 3 different platforms. Okay. So from here, I need to work on 3 different procedures. Let's do it quickly. Because I need to create, let's see what we need to create. We need to create those cooperation platforms, this one, those 3. Then we need to create this second one, which is going to be the emissive one. And then we need to split the smallest island. So basically we need to create those 3. Okay, let's go to the bigger one, I think. Okay, for the bigger one, what I will be doing is I will use a multi-bounding box here. I will convert it into a bounding box. The good thing about this is that we can increase subdivision here, and subdivision here to give it more resolution, just in case. Then I will transform it. I will scale it up, maybe in Y direction, maybe 5. Nice. I will be using this particular model to do a Boolean operation. Okay, that's what I'm doing. I will copy this transform node here as well. I will increase this like a lot. And I will copy a third one, which is going to be smaller. Right. Let's save the file here. And the next part. Again, BDB. Yeah, we're going to work with BDB like a lot. I will be using resample as well. Okay. Let's keep this simple. 0.01, that's okay. Maybe 0.01, just to have better results. Let's wait. Hopefully it won't take too much time. Great. Okay, not that much. Maybe 0.15. Great. Now I have the resample node here. I will repeat this process 3 times. Here. Then I will turn this off to copy 3 times here, 1 for each one of those. Yay. So I will go like 0.1 here and 0.1 here, just to make this run faster. Okay. Okay, now I can reduce the values of this BDB, maybe quite a bit more, like that. That's nice. And for the third one, let's do it again. Oh, this looks terrible. 0.02. That's great. Okay. Okay, let's continue. So what's next here? What I will be doing here, it's let's come on. Nice. Let's see. Box is here. Okay. This is really cool because what I will be doing, it's I'll do a Boolean operation between volumes between those BDBs. It's possible to do it. Sometimes when you have problems by intersecting general geometries, you can convert them into BDB, and you can do the same process of Boolean operations here in as BDB. So before doing that, I will be using a reshape node here. I will increase a little bit, not the delays, but the erosion. Yeah, that's great. And if we go to BDB, if we tap BDB, we will go to, yeah, we have this option. It's called BDB subtract. Let's grab it. And I will put the bigger box here in the first one. And yeah, something like that. If for some reason I try to do this, oh, come on. If for some reason I try to do this, and let's go to general. Oh, what happened here? Okay, let's work to, I don't know what happened here anyway. Let's build the model here. Weird. I don't know what happened here, so I will open again my network view. Let's go to landscape. Let's go to hide objects. Right, in here I need my geometry spreadsheet. Inspector, geometry spreadsheet, that's nice. Okay, I didn't know what happened here. 0.5, 0.8. Let's go to view. Let's go to, no, I need to go to layout. Tools, grid lines. Okay, that's nice. Okay, if I try to do this with a surface, probably it would take more time. So that's why I'm using the BDB as an alternative to do Boolean operations. So then I will reshape. Again, my volume here. I will use a road to make this even better. That's nice. Come on. I will save my file right now because it's quite a bit slow. Right. Right. So now it's a good time to convert the BDBs. Let's go to polygon here. Let's see. Ooh, like a lot. Doesn't matter. Doesn't matter. Okay, let's continue. Let's continue. Where I was standing here. What I will do here, I will use a delta mush to finish this part. We're almost done. No worries. The render part is going to be faster for now. And we have this another part, which is the islands. Those are the islands. So near here, I need to go to convert VDB. We don't need to do anything else here. But probably here it's a good thing to use a delta mush to clean this model. We're almost done. Let's put it like 30. Finally, I will be using an attribute triangle because I want to activate the alpha channel here. I will be using a channel for this particular thing right now. This is the way to call an attribute and to create a slider as well. So now if I go to this flat shaded, I won't be able to see nothing, but if I increase this value, I will barely see my model. That's nice. Let's save the model here. I will transform my model here because I want to move it vertically. Maybe minus 0.15, just a little bit. And here I will transform this little guy. I need to reduce it. I need to poly reduce it. How many polygons do we have? Let's try to go back to the convert VDB. And let's try to go like increase a little bit the adaptivity. Just to see if we can reduce the amount of polygons. Yeah, that's better. Okay, that's better. A lot better. Okay, so what I'm planning to do here, let's see if I can increase. Let's delete this one. Let's delete like 1. Maybe 2. I want it to be quite a bit bigger. Hopefully this works perfectly. Okay, that's better. Anyway, my idea was to split the plane, but probably it won't be possible for now. Anyway, doesn't matter. Doesn't matter. I will try to move this very quickly. For now, let's try to put those transform nodes together. And what I want to do here with this plane, I will separate and I will split the biggest plane with the smallest. So I will be splitting based on areas. Okay. So the way to do it is by using delete small parts. This node it's from the labs. So what I need to do is I want to extract or separate models based on area, but I need to set a threshold here. So here we need to test. Okay, 1,000 is like a lot. Let's go to 50. Oh, that's nice. Okay, it's perfectly done. So I can use the same node here. I can invert the result. So that's nice. Perfectly done. So for the final part of this, as this is just one model here, I was in the exercise that you may see in this example, you will see that we have 3 different platforms. It's because I increase this general size of the middle island. So when I do the splitting, the Boolean process here, I could split the biggest platform in 3 parts. But for now, here I have just one, but it doesn't matter. Because for now here, what I wanted to do with this part very quickly is I want to move them vertically randomly, but I want each part to move vertically with different values. So this is a really cool thing to do. So what I will be doing, I will be using for the first time a for each loop. Okay, here I will be using the for each connected piece. This will help me to control each one of those small islands. If we may see here, for example, if we use this for each loop by default, if we go to the for each end, if we activate a single pass, we will have the possibility to see each one of those particular units. I don't know. Probably we cannot see anything in the viewport, but here in the geometry spreadsheet, we may see that something is changing. So I'm selecting different objects. Okay, that's nice. So what my idea here is to move, so that Houdini could move each one of those islands vertically randomly. That's why I need to use the for each loop. So what this will do, it will grab one island. I will put a transform node here, and I will move it randomly between a range from, I need to decide from -1 to 3. I don't know. I need to decide this range. Then, so Houdini will choose a random number here. I don't know, 0.1. Then it will go to the next one. It will apply it. I will transform it. It will move it from this range again, but it will choose a different number, like 2, for example. And with this process, I can apply this logic to each one of those islands. Okay, that's what I'm going to do right now, and that will be the end of Houdini, of the Houdini part. So I will try to do this quickly. This is not that hard to do, but we need to put here a transform node. Nice. So if I move if I change my translate node here, parameter here, you will see that everything will start moving. Okay, that's great. But I need to set something here that will give me the possibility to move things randomly and with different values. Okay, so the way to do it, first of all, we need to activate something that is called meta import node. Okay, just stick with me for this part. I won't explain the logics behind it for now, but bear with me. If we want to apply different values to each one of those islands, we need to activate the meta import node. So here we have something that is called iteration. We need to play differently with each iteration. Okay, that's basically the amount of units we have here. So the way to do it, I will save my file here. If I want to move them in the y direction, I will click on it, Alt-E to open this window. And here, we need to say something like, we are going to work with a detail. This detail. Inside the detail, we have iteration that we need to run differently each time. So here we need to set inside the detail, we need to run the for each loop. It will call for, okay, this one. We need to work with the begins metadata one. That's the name. Okay, that's the name of this particular one, this particular node that I already activated. For each begin metadata one. This is the node we're going to work with. Then, comma. We need to call the iteration that it's stored inside the detail. Then we need to set the index, the attribute index, that by default is 0. Okay, let's put it 0. Then what I want to do, I want to randomize whatever is happening here between a range. Let's go to -2, to 3. I don't know. And then I will store this. I need to fit this value. Okay, so let's apply it, and you will see that each one of those islands move randomly vertically. Okay, if I want to change, if I want to reduce the range, I need to reduce this amount. Maybe quite a bit more, between -1 to 1. I think that's enough. Great. That's great. And we have it. We have the biggest one. We have general islands, and we have this one. I will merge them all together. Nice, nice, nice. Okay. Cool. Cool. Now, if I go back, I will have my whole model here. So let's go very quickly to Maya. Okay. I will try to do this quickly because we don't have time. So I need to use the FBX wrap output. Let's select this one. Let's select the other one. And even though here, let's select this one. Okay, let's go to wrap here. Let's select the third one. Okay, got it. How many points do we have here? That's great. That's great. Should I reduce this one? Okay, let's try to poly reduce. How many points do we have here? Okay, let's reduce it to 40%. It's working fast. Yes, nice. Great. Okay. So here I need to select my output. I will create a new folder here. File 2. This will be build-in1.fbx. Save this one. I have my file 1, save to disk. Let's go to the next one. Number 2, save to disk. Let's go to number 3. Save to disk. All right, let's double check it. Let's go file 2, 3 of them. That's nice. Let's go to the next one. I will copy this note to make things faster. I will paste this into here. This is structure. Oh, but not that one, the output one. Yeah. That one, yeah, the smaller one. A structure 1, save to disk. Let's check it out. Structure 1, that's nice. Let's copy this node. Let's go back, landscape. Let's paste it here. From it to it to it. Nice. Let's finish this. This is structure. No, this is landscape. It's a landscape. So I will copy these 3 times better. I think it's better. Yep. Landscape 1, save to file. Landscape 2, save to file. 3. Yeah. We are ready to create our, yes. We are ready to create our final file inside Maya. I will try to do this as quick as I can because we ran out of time. There is no time for us. Okay. Sorry for being that late. Okay, my Maya is loading and let's finish. Let's try not to create any kind of harder material right now. Probably the middle one. I will apply a texture that I downloaded from internet. So let's go to new one. No, I don't want to save it. And from now, let's save the file. We're here. File number 2. Okay. Here I need to import webinar, file 2, build-in 1. Let's wait. That's perfect. 2. I'm pressing J, by the way, just to repeat the last command. Nice. And structure. Cool down. That's nice. Oh, that's perfect. And it's quick. Yeah, it's really smooth. Nice. I will save the file here. Let's quickly go to Arno. Let's activate SkyDome. Let's go to the color file. I will select the same HDRI I've been using. That's nice. Next, I will go to render setting here. I will go directly to GPU. I will put here 20 camera samples. That's the best thing we can do here. And let's apply some materials. Here, I will go to assign new material. Arnold shader, standard. This will be called platform 1. Got it. And I will be using a copper preset. Okay. Probably I will be increasing a little bit the roughness, and probably I will be playing with the thin film. I am doing this by memory, by the way. Then let's see more or less what kind of materials we use here. Yeah, we have a kind of purplish material here. So maybe what we can do there is we can create, maybe we can go to, let's select it, yes, this one. Let's go to new material. And maybe here we can play with another shader. We have this shader that it's called Car Paint. Good thing about Car Paint is that we have the possibility to create flakes. So our final render will look really cool. So let's do it very quickly. Maybe we can create some magenta and magenta flakes, and we can choose this as a dark blue. Yeah, something like that. Maybe we can change this color to sky blue. Maybe I like it. No, maybe quite a bit more white. That's nice. That's nice. Maybe we can increase the IOR a little bit. I am just placing all these values depending on my notes that I have, just in case. On here. And let's continue with the general structure down here. The general structure, let's apply a very simple material here. Let's apply a very simple material here. Let's keep it into white for now. And here I need to apply a transparent material. Okay, let's apply a transparent material or a glass material. So let's go into assign new material. No standard surface, let's put it glass. And we can use a preset here. If we go to frosted glass, what we can do here in the transmission, we can change this value. Maybe we can make it more greenish, or something like that. We can increase the IOR, reduce the roughness probably. And yeah, I think that's more than enough. What else? Oh, the structure. We can select it. Let's go to new material. Arno standard surface. Let's work with the copper for now. And this one, apply new material. Let's go to standard surface. And let's select, where's my gold? Oh, it's here. Okay, let's select the gold material, but I will increase the roughness. Okay, let's put it into 5. And to finish, I need to apply, I want to apply a texture here. I have a texture. Where is my texture? Okay, let's see why it's not loading here. Oh, yeah. I have some file. I have a texture here. I want to apply this texture. Okay, this texture that I found on the internet. You just, if you want to use this particular texture, just look for ink patterns, and you will find this kind of texture. So I want to apply this texture on it. By the way, this is the texture that I apply on the exercise, the same texture. Okay, but it's emissive. So what I'll be doing, it's let's look for the file. I don't remember what it is. Yeah, it's there. So for this particular material, Let's go to the Arnold shader. I will put it like emissive. Okay. Emissive one. Emissive one. So here I need to save my file, go to the hypershade. Hopefully this won't crash. Hopefully. Okay, where is my emissive one? This is the one. Yeah. So what I will be doing here, let's apply the texture here. This is my texture. Nice. But if I want to work with this kind of texture, what we need to do is to first we need to create the UV mapping. Okay. So we can another way to import a particular texture is by using the image node. Both of them are welcome here. I will copy this. Why it's not working here? Okay, let's say to go to webinar. This one. Okay, that's great. I don't know why it didn't want to work. Okay. Both methods are allowed here. In this case, I can control the placement with this node. In this case, I can control the map size with this UV coordinate. So next. If I want to apply it to the emissive material, I need to use a UV projection here. This is the way to create a UV mapping fastly. Color output goes to the white dot here, color projection. Then this color will be part of the transmission color, transmission scatter, and emissive color. Okay. Then here in the emission, I will increase this to 1. Or as you may see, something is happening here. And probably I need to reduce the weight. Yep, something like that. Great. So let's see. Let's try to create some final, let's do some final tweaks here. I want to have emission inside the building. As you may see here, my building has emission light inside. So what I will do very quickly, I will copy this structure and I will reduce it manually. Doesn't matter. Okay, and this particular model will have a new shader. This will be emissive 2. And just increase the emissiveness of this material. Simple as that. Then let's add some dramatic light down here. Let's press J. Oh, come on. Where is it? Okay, it's here. Let's press J to rotate it. We're finishing. No worries. We're almost done. Okay, probably here I need to increase this value, maybe quite a bit more. And finally, one last model here. Let's rotate it. Make it bigger. Disk. Something like it. Almost done. Let's try to create a camera. Create a camera. This will be called axonometric. Let's go to panel, axo, to be sure that it's working. Let's go like really high value, like 120, because I want to make this more I want to make it more asymmetric. What else? I think we forgot to do something for the roots. So maybe let's try to keep it this very simple. So let's keep it like that. I mean, I will add quite a bit of metalness. I will reduce the roughness. Okay. I would like to work more about it with it, but we don't have too much time right now. So let's put it like it. I will select my sky dome. Let's go to the camera. Let's press off. And let's put it like it. Let's go to Arnold, utilities, pre-populate GPU. This won't take too much time, at least for me, it shouldn't take too much time. This particular process depending of your GPU. You can spend here some minutes waiting. In my case, this is really fast, less than a minute. Okay, almost done. Nice. Let's go to my render settings. Let's go to a square format. I think let's select some AOVs that are basically my maps. Let's select the ID. Normally, I also work with diffuse. I also work with the diffuse indirect. I work with the emission light as well, emission map. I also work with the transmission. What else I'm forgetting? It code CPU, diffuse. Well, diffuse, direct, and indirect. And basically that's what specular, sorry. Specular, direct, no. Those are normally the maps that I normally use when I rendered. Okay, let's go to 25. Let's save the file. Let's open the IPR. It's the axonometric. And this should work. Hopefully it will work. Okay. Okay, something is happening on my texture here. Let's see what's happening here. Let's go to let's do a very quick tweak here. Okay, first of all, this material, it's not that good. It's better. Let's see if by changing this value, it will help me to make it better. It's perfect. That's perfect. Then, okay, let's try to change the material back here. I didn't like it. Let's go to Chrome. I will increase my roughness. Yeah, more or less like that. You can increase in film a little bit. Then we need to fix whatever is happening here. So let's stop this and let's go to the hypershade and let's finalize it. Okay, my projection map, it's in planar. Probably I need to change it from planar to spherical. No, cylindrical is not working now. Let's go to cubic. Oh, even is not working. Okay, shrink wrap, that would work as well. And maybe here I need to change the angle. No, that's okay. No, that's nice. I mean, that's working fine, but I don't know how it's working like that. Because planar is not working perfectly. That's weird. Okay, let's keep it into spherical. Let's see if by changing. Let's see if by changing some attributes here, UV coordinates. Maybe let's see if by scaling this. Okay. Okay, for some reason it's looking like cylindrical. Weird. Weird. Okay, but at least it's better. At least it's better. So probably here for me, it would be better to add more emission. No, let's keep it into 1. Or what we can do is we can test a completely different material here. I have another. Oh, let's use this one. Let's wait a second while my render it's updating. What happened here? Okay, that's more or less better. Keep spherical planar. I don't know why my planar is not working for you. It's not working. It's supposed to work. Okay. Okay, if for some reason the model is not working as it's supposed to work at this one, we have another second option. What we can do here, it's let's grab it, Control-1. Okay, I'm finishing with this. Okay, I will create a UV mapping manually here. So what I will be doing here, let's select the model and let's go to UV and let's try to select maybe automatic. No, let's set to the best plane. Hopefully this won't crash Maya. Hopefully. Hopefully. Come on, you can do it. Come on. Okay, it freezed. Yeah, that's why sometimes I don't want to use the UV mapping option here, but rather try to solve that issue in the Arnold render instead of using this. Yeah, because this will crash my computer. Okay, let's see. I don't know if we have more time here, because I really want to spend time in the Q&A section. I don't know, Mike, if you're here. Should I continue or should we go directly to the Q&A part? What do you think? I don't know if you're here. If not, I could try to solve this. Let's see. Up to you. Okay. Okay, I will try to solve this particular part. I will close this one. I will try to solve this part very quickly. If this takes too much time, probably it would be better to go to the Q&A part. Okay. Because on this part I need to test several times these materials, but I don't want to spend too much time on this part. Okay, let's save this file while this is loading. Let's save this file here. I will share with you all these files. Save this. Save this one. Let's wait. We close this one. I need this one. Come on, Maya, you can do it. No. Okay, let's try to select it again. And let's go to modeling UV. Let's go to probably spherical. Nice. So on this part, what I will be doing, I will increase this value to its maximum and this one to its maximum. Okay. Yeah, the problem here is that I'm creating a kind of spherical reaction, but hopefully this will help. So now I have my UV mapping set. Let's go to Arnold again. So on this particular part, I don't need this UV mapping anymore. Let's erase this. Let's control everything from here. Let's use the control in the transmission, the shutter, and the emission as well. So let's reduce this. Let's see. Save the file. I will stop this because this is running my CPU. This is making my CPU to make some noises. Arnold, utilities, populate GPU cache. Let's wait a couple of seconds. And we are almost done. Come on, you can do it. Okay, let's see if that helped. Let's wait a couple of seconds here. No, it didn't help. Why it didn't help? Okay, I need to check this file because it's doing something weird here. Let's try to select another texture to see if this is working. For some reason, it's not working as it's supposed to work. how it could be. Okay, I don't want to spend too much time trying to look for the answer here, but probably by using again my projection node here, I can solve it. Let's try to change it from planar to shrink wrap. For some reason here is working fine, but for no reason it's not working fine here. Okay. Okay, guys, I don't want to spend too much time here trying to solve this. This won't help. Okay, let's do something completely different because I don't want you to stay with this. This doesn't look really good. Okay, let's do something different. Let's change material here. Let's change material here. Let's go to new material. Standard surface. Let's try to create. Let's try to create here a more transparent material. So what we can do here, let's change the metalness. Let's reduce the color here. Let's go to transmission, activate transmission. Let's go to color. Let's try to change it to more greenish color. That could be a solution. Yeah, that looks perfectly nice. So we can play with the IOR in order to look like we are adding a kind of texture on it, even though we are not adding any kind of texture here. I think that's more than enough. Maybe we can add a little bit mission. No. Let's keep it like that. Let's keep it like that. And let's work with, let's try to finalize with this material. Let's try to organize it. Maybe let's try to add more, increasing the roughness, more or less like that. Not emission, but the thin film. Yeah. More or less like that. And even we can go to code, we can create a second layer, and we can reduce the IOR to create a very cool effect like that, more or less like that. Great. Let's go to that. Nothing bad. Okay, let's go into it. Okay, let's try to finish this by looking at it from the top part. Let's select this particular material. Let's go to flakes. Let's increase the density a little bit to make it more interesting. Let's increase the roughness here, and let's increase the roughness here as well. Okay, that's better. It's better. Then we can select the transparent material here. We can make it quite a bit darker. We can change the IOR of it. Something like that. And we have another emissive material inside it, which is this one. We can increase, yeah, like it. Let's put in more greenish color. Yeah, we're almost getting there. Okay. Let's put it like it. Okay, that looks nice for me. That looks nice for me. Okay, let's keep it into that. More or less like that. And finally, let's try to look for, let's keep it into it. I will go to perspective and I will try to look for the best rotation for my IOR. Yeah, that looks nice. That looks nice. Okay. Yeah. Yes, I think that's more than enough. I will try to organize this to it. Cleaner. Into it. Okay. Okay, I can stay the whole day here looking for the best, looking for the best orientation. So, okay. Okay, guys, I will be sharing with you those files as well. So you can compare whatever we did previously with the last one. Probably is better to change the color here. More warmer color here and reduce the spread to make it more dramatic to the center. I think that's better. Okay, guys. I think we can finish this part while this is rendering. Let me see if my audio is working fine. Okay. Okay, I don't know if someone has questions or not.
Awesome stuff. Does anyone have any questions? You can ask them in the chat, or if you want to raise your hand, you can also ask by camera or microphone, or just write it in the chat.
You can ask in Spanish if you want. I will translate. Or not.
Very cool workflows to work.
Thank you so much. I would like probably maybe later in another session, I would like to share how to import whole subnets from Houdini to Maya. That's really powerful when you do that.
Sure.
When you start using subnets and digital assets from Houdini to Maya.
Yeah.
Okay. Well,
seems no one has any questions.
Oh, that's nice.
Oh, is there a way to import animations? Yeah, Alembic.
Yeah, yeah, you should use Alembic.
It doesn't work with Apprentice though.
Yeah, exactly. That's the only problem. But in the file that I sent, in the folder that I sent to you guys, you will find some ABC files that are on Alembics. In case you want to import them, you need to go to, let's see here. You need to go to the cache option here, Alembic, and import Alembic. Okay, that's the correct way to import animations.
Yeah, Alembic is animation file, goes to most software. So, but to make it in Houdini, you have to have at least indie version for Alembic and FBX.
Someone is asking what's the best way to import what we make to Unreal Engine. It's by OBA. I normally use FBX as I can.
I mean, we're using VGO with Houdini Engine, but FBX would be the other way.
Yeah, I think the best way to do this kind of operation is by using digital assets from Houdini to any software. I mean that's the best part of using the Houdini engine, but you need to have license because it's working. That works with the indie version, at least from the indie version. So you can export the whole. Literally, you can export the whole Houdini. You can pack the whole Houdini power and export whatever script you're doing from Houdini into 3ds Max, Maya, Unity, and Unreal Engine as well. I don't know if that works with other softwares, but what I know it's at least those 4 works pretty decently. Thank you so much, guys, and thank you so much for staying here. Okay, so please, if you have questions later, yeah, we said FBX. You can DM me anytime on my Instagram account. Do it anytime you want. Gracias total. Thank you so much, guys, for being here. Okay, I will stop sharing my screen.
It was a lot of fun. Everyone seems to enjoy it.
Thank you so much, guys, and thank you, Mike, for the opportunity.
Of course. Well, in that case, we can end it, and of course, you'll get the recording when it's done, emailed to you. Other than that, yeah, keep
Okay.
up with Pedro online.
I will send these final files to Mike so you can download them later from the same Dropbox file, right?
Yeah, I'll
Cool.
put it.
So thank you so much, guys. Lunchtime for me now.
Enjoy.
The best part for me. Thank you so much. See you
Thank
later.
you, everyone.
See you
Bye.
later to all. Bye-bye.